Okay, good afternoon, everyone in Singapore, and good morning to our colleagues and friends from Norway. Welcome to the last day of this 2 weeks Norway-Singapore Science Week. This session will be recorded and it will be made available on YouTube after the recording. My name is Per Lund. I'm a Science and Technology Counselor at the Norwegian Embassy here in Singapore. And I'm very pleased to have so many good presenters, so many good presentations today. The theme of today is actually we are going to have 2 sessions. We will have a session on ocean technologies from now until 9:30 Norwegian time, and for 4:30 Singapore time. And then we will directly go over to the second session, which is addressing sea level rise and also ocean policies. But without further ado, I'd like to give the word to this session's co-chairs, which is Professor Alan McGee, who is Director of TCOMS, the Technology Center for Offshore and Marine in Singapore, and also to Dr. Arne Fredheim, who is a Research Director at Sintef Ocean. So with that, over to you, Alan and Arne.
Okay, hi everybody in Singapore and Norway. Welcome to this session on ocean technologies. I think we have a great lineup of speakers, and so I appreciate everyone's time for joining in and contributing. So there will be, each presentation will be followed by a short period for Q&A if time permits. So please feel free to type your questions or raise your hand if you have a question for the end of each presentation. And with that, I think we'd like to have our first speaker, who is Ying Quan, who is going to talk about aquaculture in Singapore environment, I believe. So over to you.
Thank you. Okay, well, just give me a second while I share my screen.
Yeah, we can see.
Perfect. Thank you.
Okay. Well, good day to everyone. My name is Ying and I represent Barramundi Asia. We're just in process of being rebranded to Barramundi Group, which is why you see the logo as such. And in the company, my responsibility includes, business development, government relations, media relations, and I'm also part of the whole production team as well, doing management control and planning. So this is the agenda that I'll briefly bring everyone through today. I'll be covering first briefly about our company, and then diving into Singapore's aquaculture ecosystem. After that, I will also go into some of the infrastructure and R&D aspects in the ecosystem that everyone may be interested in as well. So let's start immediately. So Barramundi Group is actually founded in 2008 by 2 Dutch gentlemen, and they were previously both from then Marine Harvest, now MOE. I think respectively the Group CEO and Asia Pacific CEO. So that's Mr. Hans Beeman and Joop Stammen. So both of them landed on in Singapore and decided to found Barramundi in Singapore, and thereby setting up Singapore's first marine or sea cage aquaculture company. So fast forward now, we've grown quite a bit, acquired a few more farm sites both in Singapore and overseas. And overall, what we really want to do as a vision is really to make Barramundi the most sustainable farm fish in the world. We're definitely not there yet. There's a lot of work to be done. And in the shorter term, we want to, create Barramundi to be the salmon of the tropics. So some of the key highlights, as you can see, we have achieved PAP 4-star certification. We've secured over 6 leases across 3 countries, which I'll elaborate later. We also have a subsidiary called UVAX that develops autogenous vaccines. And at the same time, earlier this year, we also acquired a startup called Lego Aqua that basically breeds a better strain of Barramundi. At the same time, our sales channels goes over to 9 countries. We have 5 retail brands, and we have basically done the e-commerce farm to fork whole supply chain since 2015 in Singapore. So going right into what we do, our business model is very simple. We farm and we sell fish. So these are just some examples of the products that we offer as part of our Singapore brand, Kubara. You guys can also check out the web shop at kubara.com as well. So in terms of our farm operations, we are in a way bounty side, both in Singapore and overseas. In Singapore right now, we have 3 sea leases. That's one in Pulau Semakau, off Pulau Semakau, Senang side, and we recently secured a new sea lease off St. John's Island. At the same time, we also have a land-based nursery on Pulau Semakau itself. Also, through our acquisition of Allegro Aqua, we have a land-based nursery and hatchery also on St. John's Island. We also have a footprint in Australia, and back in 2018, we acquired Australia's largest ocean-based farm, that's Marine Produce Australia. And currently, we are also developing farm sites in Brunei. At the present moment, we are developing our land-based nursery, and subsequently in 2021, we are looking forward to build up the whole grow-up portion out in the sea. So overall, we have been consistently expanding, and to us, we have a goal of producing over 10,000 tons of fish by 2030. That's a very aggressive target, and we are in the midst of actually doing our fundraising right now. So this is then a snapshot of all the capabilities that we have built over the years. With the recent acquisition of Allegro Aqua, we have now incorporated broodstock and hatchery into our capability set. We also do our own vaccination, as explained, and we basically control the entire supply chain within Singapore as much as possible, all the way until consumers. Okay, so now moving forward, let me share a little bit more about Singapore's ecosystem. In general, Singapore's aquaculture ecosystem is actually very young and small. Over the past 10 years, starting from 2009 to 2018, the industry, in terms of production, only grew by 4% CAGR on a year-to-year basis. And currently, we only have about 121 fish farms, producing 10% of a total food fish consumption. That adds up about 5,000 tons. So you can see in the map, those are the limited areas that you can farm in Singapore. The majority of the 109 sea-based farms are actually coastal farms. And the 2 red dots in the south of the map, at Pulau Semakau and Pulau Senang, those are actually Barramundi Group's farms. So in total, in terms of sea space, all of it added up together is only about 100 hectares. In terms of our sort of infrastructure and research ecosystem, there are plans for us to develop, I think the coloring is a bit off here, an agri-food park in Sungai Gadut down in the future that was announced by the government, where there could be high-tech greenhouses as well as nurseries and hatcheries located there. At the same time, in terms of R&D partners, in Singapore, we have the Temasek Life Sciences Laboratory and also the Aquaculture Innovation Center. So these two are specifically focusing on aquaculture problem statements. At the same time, on St. John's Island, where we are also co-located, there is also the Marine Aquaculture Center led by Singapore Food Agency. So I won't go too much into detail about the main species farm in Singapore, but it's a mix of both freshwater and saltwater fish. And Barramundi is definitely one of the higher volumes fish produced and exported. So this slide gives you an overview of the stakeholders, the main stakeholders, main government stakeholders in Singapore, and sort of their strategy and approach. So in general, aquaculture as an industry, it's both for economic development as well as for food security. I think many people might be aware about Singapore's 30 by 30 strategy. That is an initiative spearheaded by the Singapore Food Agency. But more than that, actually, the Ministry of Trade and Industry, with support from EDB, Enterprise Singapore, and also A-Star, we're also looking at developing Singapore into the hub for aquaculture, where economic opportunities, whether it is startups, it is novel farm systems, farmers, can actually develop in Singapore. And of course, this is done in an ecosystem approach, where private, public partners all come together, startups as well, are put together to really develop this ecosystem. So let me just jump in to introduce some of the different innovations that we have seen emerging in Singapore. I would share with you guys all the coastal farms. I think many of you guys will be familiar about how a coastal farm look like. So now what I'm showing you here is an inland RAS system. This is a local SME called Blue Ocean Aquaculture Technology. Basically, they are farming high density in a flatted factory within Singapore. So this is something that a lot more farmers, they are coming in to develop such innovations. And to take this a step further, we also have a company called Apollo Aquaculture Group that's doing also inland, also RAS system, but multi-story setup. And what they have done is that they're actually planning to launch the multi-story system as high as 8 stories in total. And the photo here is really their prototype that is actually 3-story to 5-story tall, if I'm not wrong. But the 8-story that I mentioned is really currently being developed, though it's not launched yet. But those are, I mean, that is one of the most aggressive, I would say, RAS business plans that has been executed in Singapore so far. So aside from land-based system, there's also floating closed containment system. Basically, these are tanks on a barge, but this is closed containment because they also adopt a RAS system. And this company is called the Aquaculture Center of Excellence. And I think, as you see in the photo, the tanks out there, these look like 100-ton tanks. I haven't visited myself, unfortunately, but they are one of the newly developed upstarts in Singapore. They have been developing the technology over the past 3 to 4 years. At the same time, so this one is literally tanks on a barge. This is a floating flow-through system. This is launched by Singapore Aquaculture Technology, and they also, I think last year announced partnership with Siemens to really inject, I think, computer vision as well as IoT to do smart farming. And lastly, there's us, of course. We're the only ones, as I mentioned again, in the south, doing the kind of open sea aquaculture that is more typical in Norway now. So aside from those players, let me go a little bit into the infrastructure and R&D. I think that the main R&D facility that most people will be familiar with is the Singapore Food Agency's Marine Aquaculture Center on St. John's Island. Actually, in terms of pure hectareage, I think this island facility could be, I mean, correct me if I'm wrong, could be the largest R&D facility for aquaculture in the world, actually. So this facility was actually launched in 2003, and Singapore Food Agency actually does quite a few R&D activities here, whether it's genetics, hatchery, and also nutrition. But at the same time, the whole facility is built to allow for private companies, research institutes to really go in and also perform aquaculture-related research. So those are purpose-built facility with guaranteed seawater intake. The facility managements are provided. There's a co-working space as well, and MAC and SFA also provides you with, the live feed and also any kind of technical support that we need. So as mentioned, we are also members of this facility, but we're not the only ones. There's some examples I provided. Adisio recently launched their center, I think last year on the facility. Temasek Life Sciences Laboratory is also part of it, and there's also a lot of interest of startups wanting to set up shop to do research and development here as well. So to us, the value here is really because the infrastructure is great for our hatchery and nursery production, but at the same time, I think the ecosystem is really being built up for a lot of that knowledge exchange to happen. Well, next, there's also the Aquaculture Innovation Center. And I also like to especially mention ASA's SIFB, Singapore Institute of Food and Biotechnology Innovation. So what I'm showing here, it's more of the Aquaculture Innovation Center. And this is a center that was launched actually recently last year with Enterprise Singapore's support. And what it is really an applied research center. And it brings together all of the expertise of Singapore's Institute of Higher Learning and research organizations into one entity to really come together to help solve farmers' issues, basically. So this is more of a collaborative approach and also a partnership with the industry. And similar to MAC, a lot of these facilities here could be rented out by industry partners. At the same time, they also provide a lot of technical support to industry partners. So this is going to be my last. Sure.
You have 1 minute left.
Okay. So this is actually my last slide, as I was going to say. Some of the recent developments I just want to share with everyone in the ecosystem. So recently we partnered with Louis Dreyfus and Temasek Life Sciences Laboratory on aquafeed research. As I mentioned earlier, Adisio also set up their facility in Singapore. There are many other of such, happenings in the startup space as well. We also have the Hatch Blue Aquaculture Accelerator, which I think most of you will be familiar with, also getting support from Enterprise Singapore and setting up shop last year. So I think there's a lot of things happening. But overall, I'll say that the aquaculture industry in Singapore, it's very young, still very nascent, but definitely has a lot of growth potential to be the hub that supports the aquaculture growth in across Asia Pacific. So that's the end of my presentation. If you have any questions, you can feel free to drop me an email or add me on LinkedIn.
Yeah, hi. Thank you very much for that's a great presentation. I visited one of the fish farms on the north coast. That's one that you cited there. It's quite enticing to me to be able to have some local fish, fresh fish supply, because I love to eat fish. So I think we just have time for maybe one question, which maybe I will pick the one from Paul Ong from NUS. He asked, is your group looking at other innovation of floating aquaculture structures that are much larger in size?
Actually, for our group itself, I think we have already concluded that I think land-based nursery systems and also then the mix of ocean sea cages are the most optimal for us. I think because of the sheer fuel consumption and energy consumption needed to support floating structures at this point in time, we do not think that it's economical. But that said, I think out in a sea cage, it can be quite difficult to do a lot of interventions and treatments. So we are thinking of adopting structures like these in future to do some of interventions, whether it's counting, whether it's grading, and so on and so forth.
Okay. But for the structure itself, you stick with the open cage for now?
At the moment, yes.
And then just one quick question. How large can the total Singapore aquaculture market be in terms of 1,000 tons of fish or shrimp?
That's a good question. I guess I should have included that as well. So in terms of the statistics based on 2019 numbers, Singapore actually consumes 90,000 tons of food fish, and seafood consumption per capita is about 22 kg per person. But anyway, out of the 90,000, I heard that 10,000 tons is salmon. So in terms of absolute market size, well, let's say maybe 80,000 tons.
Okay, great, thanks. Okay, Arna, over to you for the next.
Yeah, Thank you very much. And thank you for an excellent presentation as well. I think we just need to speed on and go on to the next presentation, which is Dr. Hans Bjelland, a colleague of mine from Sintef Ocean, who will give some status on the developments in new aquaculture structures. So please, Hans. I think you are muted, Hans.
How many times a day? Thank you, Arne, and thank you, Ying, for a very interesting presentation on the Singaporean aquaculture. I've been asked to talk specifically on the new and current aquaculture structures, and I will have a slightly Norwegian focus in doing that, focusing on salmon, but acknowledging that this is technology that is already being used, as you just showed, Ying, for other species and in other regions. So first, just a quick, some words about Sintef, who we are. We are a large research organization. Arne and me, we are working in Sintef Ocean. It is a part of the Sintef Research Foundation, focusing on the ocean industries. And in that, we are spanning the whole value chain. And that makes a lot of sense where we are with a number of the different ocean industries at the moment, as we see that aquaculture is much more becoming a maritime industry, requiring the competence that we have both in maritime, but also in utilizing the competence from oil and gas, for example, and the transition that we see in the industry today. But I will focus on aquaculture and structures of aquaculture today. And I think it might be useful to say a few words about the current salmon sites and production in South Norway. The production today is dominated by open pens, as in Singapore. The pens that you see on the picture is kind of the standard circular, flexible circular pens that you see all over the world. This is actually a site that we operate partly ourselves outside of Trøndelag in the middle of Norway. As you can see, it is sheltered in the way that you have some sheltering, but it's fairly exposed in large parts of the year. And what is also special is that although we farm most of the coast of Norway, we see that the technology and the procedures and the operations are fairly standardized. So a farmer coming from the south of Norway will recognize and be able to conduct his work with the equipment and with the vessels in the north of Norway. And we are still not seeing really offshore open ocean, except for some few examples that I will show you. Yeah, this has been shown to be a robust, affordable system that can be scaled. It is also used much more exposed than we are using it in Norway, in parts of the world like Faroe Islands, Tasmania, and elsewhere. But we have, and although the salmon industry in Norway is large and it's an important export article for Norway, we see that there are some fundamental challenges to growth. And that is much related to sustainability, public acceptance, and productivity. We see that fish welfare and mortality is something to be worked on. There is an issue with escapees, although very low. There is a concern that might negatively affect the wild population of salmon. We have, of course, sea lice as an important parasite that needs a lot of treatment, not to keep the farmed fish healthy, but to keep the amount of sea lice in the water in total under control. we have demanding working conditions, and there is also the need for feed resources that, as you see in most parts of aquaculture industry worldwide. And therefore, in Sintef and in the industry, there is a need to work on controlled and precise operations, which I'm not going to address that much today, and also more sustainable use of the coastal area. And we see that there's a diversification of equipment and diversification of operations there. We see that from going from the very sheltered coasts that Norway has, farmers are on the way to utilizing more and more exposed farms. And now the discussions are really open ocean and how to best make a good framework for that. But we see that, and the video will probably not work over Teams, but we see that even in modest wave heights, operations are hindered. The structures are fine, but our ability to operate the farms, and that goes for daily operations, but also more demanding operations, of course, like mooring operations and such. But every day you are required to get out there, inspect the farm, feed the fish, and although some of those operations can be done automatically, some cannot. And then you might have prolonged periods of time where you can't operate the farm sufficiently. This is the background for a research center that I myself is heading. It's called Exposed Aquaculture Operations, where we, together with fish farmers, equipment providers, service providers, and academia, work on developing knowledge and technology for robust and safe and efficient fish farming. And when starting that, the operations in name became very important because it is about being able to operate in those areas. And for us, and this is relevant, and why I mention it here as well, is that this is relevant also for other farming operations. That it's not only about the structure, but it's also about our ability to more autonomously carry out and monitor the farms, and also the interaction between structures and vessels, for example. And of course, the technology is not really that important if the fish and the people working there are not safe and sound. So a research center as this is a very good opportunity to work holistically on the challenges facing the industry. And what we see in Norway is that there is a diversification of technologies. Although the current pen designs are and will probably be a dominant part of the Norwegian aquaculture industry, we see, as also Ying showed from Singapore, that closed containment systems, either floating or land, are becoming more important, as well as other structures going more larger, more adapted to open ocean systems. But that varies from these large rigid structures as Ocean Farm, that's SalMar one, the second lower one to the right, but also to submerged systems that can, in periods of time, be submerged to avoid the harshest weather. And there was a system of development licenses that spurred a tremendous innovation in the industry, and at least these are at least some of the ones that have been granted. SalMar Ocean Farm, as you see, that is currently in its second production period. Nordlax Havfarm has just, or is producing its first batch. Aqua Design is an example of a closed system. Atlantis Subsea are testing their system at the moment. Aquatras has also produced their first batch. So a lot of these systems have now are now being designed or are already producing fish, generating a lot of experience from these new systems. And of course, as researchers, we find this extremely interesting, both because of all the auxiliary systems that needs to be developed and researched to support this, but also due to the structures themselves. Because we see that all the current designs, might be difficult to automate and might be difficult to operate in harsh weathers. They are extremely affordable, flexible, and robust. And there is a lot of industry experience connected to it. While the new concepts, they are very different and varied. And there are a lot of research questions related to these that is being worked on. And finally, just a few words about some of the methods that we use. Of course, we use numerical methods to analyze these new systems, but we see that the physics of these structures demand also that we use extensive model testing, and we are happy to have been able to test and verify most of the new designs that have been being developed in Norway. Gaining a lot of experience in studying structures with a combination of flexible and rigid bodies, for example, but also not only to make the structures withstand the environment, but also to understand how these structures provide a living condition for the fish, understanding what kind of turbulence, local current conditions that they provide for the fish. Yes, so that was kind of quick overview of aquaculture structures as we see it from Norway. Hopefully it was interesting, and I'm happy to discuss further with people that are interested. Thank you.
Thank you very much, Hans, for a very good presentation. It's nice to see get the overview of all these new innovative structures being developed. We have a couple of questions, and I think we have time. So the first one is from Tor Henrik Håvik. So how do you classify open ocean in terms of weather conditions?
There are, I didn't mention that, but there are a few different ways of classifying locations. And what we see that is there is at least two different approaches. One focusing on the extreme values, which is important for designing the structure itself. And that is typically when you look for the most extreme weather conditions in a period of statistically for a period of 50 years, for example. There is not one single definition of open ocean in that regard. But I am part of a working group at ICES that are working on such a definition globally. In Norway, we have a technical standard that is used to define exposure, which is also focusing on the extreme values like that. And in Norway, we are talking about 4 or 5 meters significant wave heights. That is kind of the limit where we are at today. But we see that the current flexible cages are being used at more extreme conditions as that. But the other way of looking at exposure is also the amount of time that you're able to operate the farm. and the amount of time that you are able to get out to the farm and such. And that might vary from region to region globally, because some parts have very acute, extreme conditions, but that is easier for submergence and such. But if you have a fish species and an operation that requires daily operations, that might be more critical, and then that might be more relevant to look into the statistics of the conditions and how often and how frequent do you have conditions prolonging for a long time.
Okay. Another quick question, perhaps, or maybe not, from Sanche. What is the range of capex and annual opex on one of these ocean-based structures? I don't know if you have those numbers, but and I guess this is something that will be part of the learning process as well.
Yeah, of course, looking at the ocean farm structure, for example, the circular yellow thing from SalMar, then we're talking about, some numbers have been 800 million Norwegian kroners, plus minus 20%, I guess. So that's an extreme investment compared to a current cage, of course.
Yes, thank you very much. I think we are just on time for 80 minutes per presentation, so I think we could give the word over to Alan. And just before the next one, I see that Quan, he answered some of the questions in the chat. So I just encourage the speakers to do that if we are not covering them online. So please, Alan.
Yep. Thanks, Hans. That was great. So our next talk is on the floating solar opportunities in Southeast Asia, and it's Dr. Thomas Reindl from NUS. He is the Deputy CEO for SERIS, Solar Research Institute of Singapore. Thomas?
Thanks, Alan, for the introduction, and it's my great pleasure to be here. I'm Thomas, the Deputy CEO from SERIS. We are Singapore's national lab for applied solar research. And I also want to appreciate Céline Paton, who helped me putting this presentation together. So we were founded in 2008, just a bit of background, when Singapore wanted to go into clean technology, and for the sake of renewable energies, we only have solar energy, and that's why we are focusing entirely on solar technologies. But looking at the entire value chain from solar cells, modules, all the way to systems, and in the system space, we have a very strong focus, amongst others, on floating solar. And that started about 5 years ago when we built the world's largest testbed for floating solar, where you see a picture here on the upper right. And that brought us somewhat in the forefront of the research. And now we are expanding our activities into nearshore and offshore floating solar. And I'll talk about that in a minute. Generally, floating solar is not fundamentally different to a land-based system. It's just that instead of piles and fixing the system onto the ground, you need floats, which hold either the individual panel or a row of panels. And there are certain perceived benefits that you have, for example, a cooling effect from the surrounding water, particularly in hot climates like in Singapore. You have ease of deployment. You don't need to prepare land. You can assemble it on land and then basically push it into the water. To some degree, you can use existing infrastructures, particularly when you combine floating solar with hydropower. I'll come to that in a minute. But then very critical becomes then, say, the mooring and anchoring, especially in areas where you have either high wave or strong winds or a combination of both. But in generally, there is quite a number of benefits. And it started eventually in countries where land is either scarce or expensive, which is, say, Japan was one of the early adopters. But that also applies for the case of Singapore. And that's why Singapore has started this research rather early, because about 5–6% of the surface area in Singapore is actually water bodies. And in order to get to scale quickly, it's easier to deploy larger scale PV systems on water rather than having small-scale systems on individual rooftops. This is just a quick overview of what we did in our testbed here at Tenge Reservoir, where we have 10 different floating types, which we analyzed for a number of years. And then, because we're an applied research institute, we want to help the industry out there. We also went out and published our results in form of a guidebook or 2 guidebooks, one market report on general, what's the floating solar industry all about and who are the players, what are the technologies. And then we also published a handbook for practitioners, which basically describes the project development process for floating solar. And this was commissioned and funded by the World Bank Group, which is also very much interested in floating solar, because that could be one of the major infrastructure technologies going forward. And as part of this work, we also assessed all the man-made reservoirs on this planet. There are databases for that, and we analyzed those. And if we only assume about, say, 10% of the reservoir surface is actually used for floating solar, we are already in the terawatt scale of PV capacity. So it's a huge opportunity, and that's why it also picked up quite a bit over the last few years. Here are some examples of large-scale systems. The largest at the moment in operation, and I happened to have the chance to visit that last year, is located in China, and that's 150 megawatts of floating solar capacity. There are different types of floats. How the industry has started is these HDPE plastic floats, and that was pioneered by Ciel in France, and has been also adopted by other countries, Korea, China, with similar designs. But then you have basically one float per module, and then you just put the module on top of each one of these floats, and you have some walkways in between for operation and maintenance. What's coming up a bit more is like number 2, where you have just a few floats and then metal structures in between, and that allows for more airflow, which in turn allows more, enables more of the cooling effect, and that brings you higher energy yield for the same installed capacity. And since we talked about aquaculture just now, so there's one innovative company from Norway, Ocean Sun, and they basically took these rings, as we just saw it earlier in the presentation, which were originally designed for fish farming, and then instead of growing fish underneath, they cover it with a mat, and then put the solar panels and lay the solar panels basically on top of it, which has the great benefit that the modules are thermally almost directly in contact with water, and thus they can leverage the cooling effect or take advantage of the huge heat sink, which is the water body itself. So for hot climates like in Singapore, solar panels which are on this mat, they operate at much lower temperature, which effectively increases the energy yield. And what we also see now more recently is that classic marine and offshore structures using steel or cement floats, that they are making their inroad into floating solar. Traditionally, those are a bit more expensive, but through value engineering, there is opportunity to get prices down and make them also cost competitive for floating solar. We also see a diversification in terms of water bodies to be used for that. So it started a few years ago with rather calm reservoirs, no waves. Now we already see larger reservoirs which have higher fetch for the wind, which have small and medium waves. And then we have now seen, and in Singapore in particular, the first 5 megawatt nearshore installation has been deployed now. It's being commissioned as we speak. And going forward, but that's at much lower TRL levels, of course, we are also looking into real offshore installations. The industry has grown quite substantially over the last 5 years, and we have surpassed now 2 gigawatt peak of installed capacity of floating solar worldwide. And the dominant players in terms of suppliers are Ciel, which was one of the pioneers, and then Sungrow from China. And then you have a whole bunch of other companies out of China or Europe or Korea. And this, you see the pie, it's quite fragmented, and A lot of innovation still happening. Ocean Sun is doing quite a number of test beds at the moment and getting into first commercial scale projects. And this is just a quick shot overview, definitely not comprehensive, but it's a huge industry already out there, specifically focusing on floating solar across the entire value chain. Now, in terms of markets, what has been installed, China is leading the pack with a big chunk because they had a top runner program, which was a support program if you do innovative, high efficiency technologies. And they installed more than 1 gigawatt in the years 2017, 18, 19. And that's why they had still have a big share in terms of installed capacity. Japan has more in terms of numbers, but smaller systems because their reservoirs are more scattered and smaller. But you see that most of the installed capacity is actually in Asia: China, Japan, Taiwan, South Korea, Vietnam, Thailand. And then comes Netherlands, which is the one country in Europe where the most floating solar activities are happening, together with France's number 2. Now, installed capacity in Southeast Asia is predominantly Thailand and Vietnam, but also upcoming Malaysia, Laos, and some other installations already happening in this part of the world. It's about 122 megawatts installed and in operation. Now, looking ahead, what's in the pipeline? So there's many countries around the world which you see in these different colors. Blue, they have planned or announced projects, and the big projects are now Netherlands, as I said, they have 2 gigawatts in the pipeline. China also close to 1 gigawatt, but already from a high base of more than 1 gigawatt. The largest announcement to date is 2.1 gigawatt in a single location in Korea and Saemangum. Laos has announced 1.2 gigawatts on a single hydropower dam. These are huge installations. Vietnam is moving into an auction system and includes specifically floating solar. Thailand has announced 3.5 gigawatts by repowering or utilizing hydropower dams. And India has a number of projects. So again, focus specifically on Southeast Asia. Thailand has huge potential, and EGAT is very much interested in floating solar, and they own and operate the large majority of all the hydropower stations. And hydropower has the benefit that by definition, you have a reservoir behind your hydropower station, which is typically not used for other purposes. You have electricity infrastructure already in place. Hydropower stations typically operate at around 50% capacity utilization factor. So by and large, the electrical infrastructure is already there for the evacuation of additional floating solar capacity. So the largest projects announced to date are the 3.5 gigawatts in Thailand and the 1.2 in Laos, but all others are catching up quite rapidly. Vietnam, Indonesia, Myanmar has announced that they're looking seriously into that. Philippines, while they have this one Laguna Lake, which you may be familiar, not too far away from Manila, that lake alone is bigger than Singapore in size. So there's a lot of people eyeing on that and trying to do test beds and trying to see what are the ways of getting floating solar on that lake. In terms of capex, so installed costs have also come down over the years, and the latest bids are in the 40 to 50 cents. If you look at these prices achieved in India and Thailand, so in the 40 to 50 US cents a watt peak, which is still a little bit more, maybe 10, 15% more than a ground-mounted system. But these prices, because the industry is still maturing, so these prices will come down rather quickly, and then very much will be moving into the space of ground-mounted system. If you then add in that the electricity generation from the cooling effect is in principle higher, your levelized cost of electricity should be comparable or even lower than standard ground-mounted installations. As I said, the industry is moving into nearshore applications. This is a real picture from a 5 megawatt installation north of Singapore, between Singapore and Malaysia, Straits of Johor. This has just been finished construction and is being hooked up to the grid as we speak. And this is, at least to our knowledge, probably the largest nearshore floating PV installation anywhere in the world. Another one, another very big one, which is also nearshore, is being planned and constructed in Taiwan. This will eventually be 181 megawatt in an intertidal zone. And this caught our attention. I mean, we're watching the space anyway, but this caught our attention particularly because this is one of the few projects which is entirely project financed. So there are banks, including DBS from Singapore, which fund or are the lenders for this project, and they do. It's entirely project financed on a non-recourse base. So this is very interesting that banks are really adopting floating solar. So what's next? Just as an outlook, as I mentioned, nearshore and offshore floating solar. And if you have followed our International Floating Solar Symposium last week, you may have heard that we have signed a collaboration agreement with Fred Olsen Renewables from Norway, and we are very happy about this collaboration. We announced it in our conference here together with Anders Spade, the CEO of Fred Olsen Renewables. So we are very happy and very much looking forward to this collaboration to bring nearshore and offshore to floating solar to the next level. Another area, by the way, for real offshore, you see in the lower right, where people are eyeing it is particularly in Europe, in the North Sea, where you have these large offshore wind farms, and they are spaced apart so largely that people are eyeing in the spaces in between to put offshore floating solar installations and then also utilize the existing transmission infrastructure. So very interesting movements. Also the combination and combined use with aquaculture, so that fits very nicely in the preceding two presentations. So there's a lot of combined uses. And we're also trying to nurture the global floating solar community, and we just launched the International Floating Solar Society, as we call it. And we are also bringing industry participants, academia together for that. So this is just a bit of an overview of what floating solar is all about. And I'm more than happy to answer any questions either right after now or later. Just send me an email. More than happy to engage with you. Thank you very much.
Thanks so much, Thomas. Great overview. There's a couple of we have a couple of minutes, so there's a question here. How does FPV energy yield performance offshore compared with inland water bodies or ground-mounted PV? Do you have any data for that?
Yeah, the energy performance, it depends a bit on the climate, but in hot climates we have seen 5 to even over 10% better energy yield through the cooling effect. And it's measurable and it can be quite substantial. It's always the question, interesting enough, it's
offshore.
Real offshore, there's only a few test installations because this is in much lower TRL levels. So in real offshore conditions, and you saw the video just now, the structures needs to be much more rugged. So this is has yet to be seen. At the moment, the main focus is more on getting these structures cost effective enough so that the deployment makes economic sense in the first place.
Yeah, I thought there was one offshore Netherlands that they claimed.
Yeah, it's also in a Slafte. It's like one of these kind of intertidal zones. So it's Oceans of Energy has just launched last year a real offshore installation, a small test bed, but this is still in the test bedding stage and not yet commercial.
Okay. Then there's, I guess, sea space is also an issue around Singapore. Have you faced issue with getting permits or floating?
Yeah, Singapore is yet to. So we did the PV roadmap for Singapore, just published a few months ago. And we also looked extensively into this available sea space. And Singapore being one of the largest container ports in the world, of course, every square inch is taken either by shipping routes, mooring, or the actual harbor activities. So what we identified also together with the authorities are so-called dead sea spaces. Dead sea spaces, if you have like a, for oil tankers, the jetty where they land, they cannot come all the way to the coast. It's probably 50 or 100 meters into the sea. And then these areas behind all the way to shore, this is not usable for any other industrial type of activities. And it's very useful for floating solar. And these are in the several hundreds of hectares of spaces which we have identified.
Right. Okay. All right. I think we need to move on. So over to you, Arne, for the next.
Okay.
One.
Thank you very much.
Thanks so much.
Yeah, thank you very much. Thank you, Thomas. We are still within floating solar. So I just give the word to another colleague of mine, Dr. Øyvind Hellan, who will tell us a little bit about test sites for ocean floating solars in Norway. So please, Øyvind.
Yeah, hi everyone. It's a pleasure to be following on to Thomas, because then I can skip quite a bit of the introductory parts, since he has covered that beautifully. And the key then would be from my side to give some insight into how Norway is approaching floating solar, which is perhaps a bit different from the, let's say, the energy demand perspective you see in Asia. Norway has a very strong hydropower production. We have a lot of oil and gas, so these natural resources are not really what is the focus here, but with this phenomenal growth of PV and this very strong commitment to move from a hydrocarbon-based energy society to a renewable, it's definite that this is also of high interest to Norway and Norwegians. What I'm trying to show here is just an overview of a few of the systems where you see some.
Øyvind, are you sharing your slides?
But, yeah, we can
sorry about that. I thought you'd enjoyed just listening to my voice, but anyway, can you see my slide? Can you see the screen now?
No, still not.
Nothing?
No.
No. Then I need to fiddle around a bit. Share content. This
Where
one.
do you have a copy of the slides? Can you share? Oh, here it comes.
Here it comes. Okay.
Yeah, thanks.
We got it.
Then let's rewind. Well, you heard my talk, I guess. So this was more or less the, let's say, another version of what Thomas has just presented. Europe has also set quite high ambitions with respect to renewables, and solar is definitely a key part of that transition. And looking at the statistics and the build-up, it's definite that solar and floating solar will have an increased role to play also in Norway and in Europe. Some of the concepts that are in play now, Ciel-à-Terre is definitely one of the big movers. But you see Ocean Sun, Norwegian company, Moss Maritime developing another concept. You have Current Solar, a Norwegian company. There are more companies coming, and from our perspective, we see this floating solar 2.0 moving from inland reservoirs, sheltered lakes, sheltered areas, to near shore and perhaps even a bit exposed. That's also an area where you have vast acreage available, and where there's a huge possibility to do energy harvesting with floating installations like this. And of course, we, from a Norwegian perspective, like to pride ourselves with a quite strong position within renewables, where at least with the, or very much so, with the upstream part of solar cell industry, materials technology in general. offshore technology, marine operations. We can build on quite a lot of the expertise built from the aquaculture industry. So this is an area where some of the Norwegians are eyeing an export market if we're able to develop concepts that are rugged enough to meet the exposed part of the floating PV market, and where we can bring a lot of inputs to bear. And there is actually a quite strong cluster of solar energy companies in Norway. So what we're seeing now is these industrial developments from different vendors. You have a very interesting concept developed by Ocean Sun, which is a aquaculture flotation ring. Then they put just a membrane inside the ring and mount the PV panels directly onto those membranes. So they're actually floating on water. And it's quite intriguing because this is actually a floating platform. You can walk on the membrane. You can work on such a membrane. So it's a very elegant and cost-effective system. Then you have other systems which are just PV panels resting on plates, floating on water. You have other kind of rooftop floating systems, and you have what I like to call ultralight semi-submersibles connected into large raft structures. Now, with all of these systems, there is a very strong push to have these tested and piloted at sea in a real environment. And the industry is pushing quite a few of these pilots. And then we have from the research institutions in Norway launched a joint initiative between Sintef and TNU, Institute of Energy Research at Hellan in Lillestrøm, and NORCE, also a small polymer research institute in Norway. We have launched a joint initiative to adapt or to take over one of these pilots and extend it into a full-blown R&D test site for floating solar in Norway. Then, of course, the general R&D thrust for such a facility is definitely on renewables, on marine structures. Social and environmental impact is definitely a very important part to look at. And also we have island communities in Norway that are currently fed by quite shaky sea cables providing power to the local communities. And the local utilities companies, they see that in the next 10, 20 years, these has to be renewed. And then they're looking at possibilities for local power generation. So what we are looking at from our side as a kind of complementary effort to what SERIS and Thomas has been presenting is to establish 2 locations in Norway for test bedding. One is a sheltered location south of Oslo, and one is an exposed location outside Trondheim. For the sheltered node, it's roughly 1.5 hour drive south of Oslo. Our focus would be on saltwater, and it's a miniature site, but just to look at the power electronics, the panel for salt water exposure, etc. And then looking at 4 units, each some 20 by 20 meters. And then an exposed node where we really would like to take these into not the open ocean, but to similar exposure as quite a few of the fish farm cage structures. So we have been looking at 3 locations outside the Trondheim fjord. This is where we have a number of, or a test park of offshore, of land-based wind turbines. This is the area where you have the first ocean fish farm cage. These, the most renowned one, built in China and towed to place, operational now for 1.5 years. And then we're looking at sites closer to these main islands. And then we're looking at roughly quarter size of full units. 2 units, each of them 50 by 50 or 75 by 75, between 0.5 and 1 megawatt peak. So just showing a bit where we are now. This is Trondheim. This is the Trondheim airport. So it's half hour's drive out here, and it's 2.5 hour drive out to this place, or you can take a fast ferry transport out the fjord. This island here, as Singapore, to give the picture of what acreage we are looking at and what we can try to put in command here. Then we've had a process with the local fisheries organizations pointing us to sites which would be, let's say, non-conflicting with their operations. And it's also quite interesting to look at this same area here. All these red dots are different fish farms. So this is a highly industrialized area, even if it's very far off the main drives in Norway. And this island we're trying to locate this is headquarters of some of the largest aquaculture companies in Norway and thus also in the world. You see also quite interesting here, there's some areas that are set aside for test bedding kelp farming. So there's quite a few interesting aspects here. And these are the wave measurements that we have in this area. 1 year, 11 months, 1 year, 9 months, 3 years. So we have a lot of data to support such an establishment. This is just showing a bit of the background. We need to get this system out of the navigational lanes. We need to look at the biodiversity. This hatched area here are spawning grounds for the coastal cod stock. So we need to keep out of such areas as well. But basically, this is a process that we are looking at, which is quite interesting to see from our side. I hope you can see the video now.
Øyvind, 2 minutes.
Yeah. Okay, I'm through with the presentation, just showing some videos of tests we have done on these structures. The first one was on quite high regular waves. This is the Ocean Sun system, where you see the flotation ring and the membrane. And then the test of same system with panels mounted. And then this is video footage from such a system in rough conditions, and it's quite interesting to see how this moves with the waves and what can be, let's say, learned from a full-scale demo of such systems. Finally, a test from another of our model basins, where we have been testing the Moss Maritime system, which you can see is a kind of series of very, very small semi-submersibles, which are then joined together into a platform. This is an 8x8 configuration of the Moss Maritime system. I think this is where I close. Let's bring up one final slide just to keep as a backdrop during discussions. So with this, I think I'll end my talk and open for questions and comments.
Thank you very much, Øyvind. So a very comprehensive talk about the plans for development of floating Ocean Sun. We have a couple of questions. So the first one, does the test bedding also include a measurement of line tension and structural stresses?
Yes.
That was a quick
Yeah,
one.
I mean, to elaborate a bit, this is why we want to extend the industrial pilots into R&D sites, because our ambition is to establish this as a fully instrumented site where different manufacturers can come in with their systems, and then we have complete measurements of the environment, the external climate, what are the mooring forces, what are the connection forces between units, etc., etc.
Okay, and then one question from Alan. Are those the actual modules in Moss Maritime System, or if not, how did you build the models?
These are scale models of their prototype. Of course, such a prototype is under continuous development, so I think the end modules will not be exactly like this. How we build them? Well, we use our standard combination of materials that we use in model manufacturing for the ocean basin. So this is a combination of divinycell and aluminium, some polymers, and yeah, different. I don't know how many parts went into this, but it's more than 1,000 parts in such a test system.
Okay, I think we need to stop there. There's a couple of other questions, Øyvind. Maybe you can answer them in the chat.
Yep, will do.
So then I think we need to continue. So I'll give the word over to you again, Alan. Please.
Great. Okay, thanks, Øyvind. And I'll catch up to you later on the model building.
I guess you will.
Yeah, good. Okay, so our next presentation is Sustainable Ocean Innovations and Solutions, and it's going to be presented by Simon Kuik, who is the Senior Vice President and Head of R&D in Sembcorp Marine. So Simon, take it away.
Pierre, can I have the slides to be loaded up here?
I will do that.
Just
okay, thanks, Prof. Ellen, and also Dr. Ani. Good afternoon, partners, colleagues, and friends. I'm grateful also to Pierre for inviting us to share our perspective from not only from a shipyard that deliver ships, rigs, and platform solution, as also innovation and engineering company developing sustainable ocean innovation and solution. Next slide, please. Yeah, next slide.
Oh, sorry, it's this one. There we go.
Thank you. Norway is our major partners, both as our user customer, technology collaboration.
You're a little soft, Simon. Can you get closer to the mic? Yeah.
Oh, sorry. Norway is our major partners, both as a user customer, as well as technology collaboration partner. And it's also an important Sembcorp Marine Innovation and Solution Hub. For my Norwegian friend, who may be more familiar with companies such as Servant SSP, LMG Marine, and Graviflow. And these are Sembcorp Marine company based in Norway, and we have offices in Oslo, Bergen, Åndal, and this team make up a significant numbers of our global 1,000 strong engineering team. Our product operation, ships, rigs, platform also operate globally, and specifically for Norway in Norwegian North Sea, Barents Sea, where it is subjected to Arctic weather, as well as Svalbard. Next slide, please. Sembcorp Marine started our sustainability journey from 2011. We integrate our sustainability program with business and operation as an integrated program to realize our sustainable growth vision and action. We contribute in two ways. One is that as a yard, we must ensure that we are safe, environmentally sustainable, and efficient. So Sembcorp Marine invested in our new Tuas yard and also innovation capability. So some of you have visited our Tuas yard. One of the key features for a green operation is to have a solar roof. And our solar roof is 4.5 megawatt peak, and our plan is to grow to 12 megawatt peak in the next few years. And also as a shipyard, we focus on technology translation and operationalization. That means at the end of technology readiness level to make all these product solutions available to our client in adapting to energy transition, as well as business transition towards a more sustainable ocean space. The next slide, please. So 30% of our company turnover will be generated from sustainable product solution by 2025. And these are example, a safe and reliable offshore drilling and process solution, LNG and other green gas energy solution, offshore renewable, and also responsible ocean living solution. And this will fulfill our sustainable commitment in protecting the climate, the earth resources, and also space where we as an organization, we make our living from. Next slide, please. So these are some of the examples. I will share more detail in the next few slides of a product solution where we deliver to our client in each of these focus areas as we transit from liquid fuel, carbon fuel to gas as interim, and to renewable as hopefully zero emission and also negative emission energy era. Next slide. So as a shipyard, our mission is to be able to protect the ocean, to ensure that we have cost-effective, safe, and reliable compliant asset when operating, whether it is near shore, mid waters, or deeper, harsher environments, so that this asset, when operating out there, does not damage the environment, whether they are in normal operation or in accidental discharge. And we have to prevent that accidental discharge when subjecting to some of the harshest weather conditions. So the picture shows one of our circular hull solution currently operating in the Barents Sea of Norwegian waters. And in the insert, it is a world first 20,000 PSI drilling capacity drill ship. That is one of the most challenging environment, operating in 12,000 feet of waters. Okay, next slide. So for nearshore, we have ready solution for electrification. But the challenge now is how do we make the battery technology cheaper for a wider adoption. So that will be a design and research focused effort. And implementation are ready for short sea and harbor operation. And the picture shows one of the three Norlec vessels that we built for Norway. These are, if you use it as a layman term, the Tesla of the sea. Zero emission ferry with power actually taken from the hydro generated grids. In total, our LMG company based in Bergen has delivered 15 of such vessels of various design, various sizes, deployed in particularly Europe, and hopefully as a wider adoption around the world in near future. Next slide. While we in this presentation, you find most people are now already looking forward to solar, renewable, and other sustainable future. But we want to emphasize as a shipyard that LNG remains as a ready and commercially viable interim sustainable marine fuel. It is here to stay for a while more. And this is also a result of decades of research and development and also infrastructure investment. And today they are ready. So today, efforts on renewable like solar, wind, and so on and so forth. With all this investment, we hope this solution will also be a cost-effective, ready solution for future. Here in the picture show that the LNG bunkering vessel is a 12,000 meter cube with a GTT membrane tank. It's being built in Sembcorp Marine Yard, will be delivered to our customer to be operated in Singapore water. In the insert is the world's largest 2 by 10,000 tons lifting crane for Harima, Snapnear, currently actually moving around the world to actually conduct green operation, meaning they are using LNG as a primary fuel, and then also the tugboats which we are investing to make our yacht operation clean. So these are some of the example of solution development, make it operational, make it available to a client. Next slide. Not only the vessel solution need to be developed, we also need to develop supporting a solution such as energy storage and energy bunkering terminals. In this case, the very first solution is a near-shore terminal solution that's designed to withstand quite extreme weather conditions from both earthquake to tsunami or ice loading. The background picture is actually a Swansbach, and that is one of the proposals that we actually developed to share with our customers, so explore the possibility of environmentally clean deployment in Arctic island. Next slide, please. Going forward, a lot of us are looking at different future energy sources. It's still not clear yet, so all this study and development will help to sort of zero in. We are currently partnering our partners to participate in some test bed and validation of some of these new fuel. This picture is one project that we participated. We designed a vessel. It's a world first liquefied hydrogen powered ferry. Currently, it's being constructed in Norway. It will be delivered soon to the client for the pioneer test bed operation. So, next slide. So looking beyond the low carbon and also zero carbon, we also are looking further down and looking at negative emission technologies such as carbon storage. And the picture show a project where we are part of the joint industry partner to evaluate the possibility of offshore CO2 storage using our circular hull as a safe and steady platform for injections of carbon dioxide in this chosen depleted oil field. Next slide, please. We earlier heard from Thomas' presentation and on the floating solar. These are currently deployed in quite more stable waters, nearer to the shore. But in Sembcorp Marine, we are focusing on delivering a offshore wind solution, both for shallow waters, which is up to 70-80 meters water, blanket structure, or in the longer term future, developing possibility for floating wind to capture the richer wind resources in a safer manner, and at the same time explore possibility to bring the cost down. I think across the various presentation, when we look at solution, one of the key words that I hear from various presentations is that cost is one important aspect in realizing any of these ideas into operation, and I fully agree with that. Next slide. Lastly, I thought it's useful to show this picture that we took when we visited Sintef Ocean, the basing tent for our circular hull solution test last year before the COVID lockdown. I'm pleased to see many of you, our chair, Prof. Hellan, Pierre, the Innovation Norway organizer for this event, and also Øyvind, who is also last speaker, and other Sintef Ocean colleagues, again online today. Good to see you. And I look forward to continue our partnership with all of you, our partners both in Singapore and also in Norway, in delivering ocean sustainable product solution. Thank you all.
Okay, great. Thanks, Simon. I have a question actually. Where do you see the challenges in the transition to the next generation renewable energy systems from your perspective?
I'm more familiar with the offshore wind, but in our perspective as a marine offshore company, solar is actually less applicable for ocean, and we can play a lesser role in that. So the entire energy that we have as an organization is focusing on the offshore wind. And in the space of offshore wind, the key is about bringing the cost down. I think in the shallow water, it has happened. It has now in Europe reached zero subsidy era, where many contracts are awarded at the commercial pricing. Similarly, as we move further out in the ocean for floating wind, where we say there are a lot more energy resources, but environmental is also more challenging. So the important thing is to bring the cost down. We will probably have to work in doubling the speed of bringing the cost down, and it is really happening. Okay, that's one. As a marine offshore company, we are very much more used to dealing with very difficult challenges for oil and gas, because they're drilling in waters of say 12,000 foot waters, 3 kilometers of waters. We are delivering structure that is of a weight of 30,000, 40,000, or even 100,000 weight. So when we deal with offshore wind, we have to relearn our skill to deal with smaller structure, and to also be able to do less sophisticated structure in a cost-effective way. So that is something as an organization we have relearned our skill set. I think that is quite a challenging thing. To go deeper is one big challenge. To go simpler is another challenge. Yeah.
Does anyone else have questions? Maybe some of the other speakers, or Arna, do you have a question?
I think there was someone who raised the hand, but maybe they took it down again, or?
I don't see the hand.
Maybe it was just by accident. Okay.
All right.
There's a lot of technical opportunities.
If not, then I'll just thank you for the interesting speech, and I think we can end the session here and give a little more time for Per to transition over to the next session. So thanks to all the speakers, and thanks to the audience for your time and attention. Hope you found it as interesting as I did. Over to you, Per.
Thank you very much, Alan, and thank you very much, Arne, for excellent session.
Thank you, everyone. Yep.
Please feel free, of course, to join the next part. We are moving away from from ocean technologies to other aspects of the ocean. We call it ocean policies, but it's actually two parts of this. One will address the challenges of sea level rise and the connection between Arctic and Singapore in that respect, and the other will also address a bit more on the ocean policies. We thank you also very much for giving us 3 extra minutes, Alan and Arne, for your session. I think we would just go directly into the next session, which is hosted by Professor Robert Beckman, Center of International Law at the National University here in Singapore, and Professor Tore Henriksen, who's director for the Norwegian Center for the Law of the Sea at the Arctic University of Norway, formerly known as University of Tromsø. So with that, I'd like to give the word over to Robert and Tore, please.
Thank you very much.
Robert, your sound is really weak.
Okay, should be all right now?
Yeah, now it's good.
Okay, thank you very much. And I thank the previous panel for some very interesting presentations. I cannot tell right now from my screen whether all of our panel are here, but I hope they are. Tari, are you with us?
Yes, I'm here in Tromsø. Good day to you.
And we do have Ben, Horton, Kristin, Richter, and Nilufer there as well.
And I believe Nilufer and Kristin are here as well. Okay, we're doing 2 panels. We're doing 45 minutes each. It's my pleasure to chair the first panel, and my friend from Trumshaw Tori will be handling the second session. We're going to move here from engineering and technology to science and law and policy. The first session is on sea level rise, connecting Singapore to the Arctic. I think the goal of this session is to explain to the Singaporeans melting of the glacier in Greenland has a greater effect on sea level rise in Singapore than in Norway. So we have two speakers, one speaker and two commentators, I think we'll say. Our main speaker is Professor Ben Horton, Director of the Earth Observatory of Singapore and a professor at the Asian School of the Environment at Nanyang Technological University, or NTU. So without further ado, we'll move to Ben right away.
Hey, good afternoon, everyone. I'm going to share my screen first of all. Can you see that now?
No.
I don't know why it's not working. Let's try again. I seem to have a problem here trying to connect mine. Maybe, Per Krista, do you want to just click through them when I say?
Per Krista, are you with us?
Yes, I'm with you. Just give me a second and I will share
the backup.
This one, isn't it?
Yeah, that's the one.
Right, so just let me know when I should change the slides.
Yeah, I apologise for that. I don't know why that's happened, but anyhow, we can go through these now. So my name's Professor Ben Horton, and I am the director of the Earth Observatory of Singapore. So many of you may not know much about the Earth Observatory of Singapore. The Earth Observatory of Singapore is a research centre of excellence. Funded by the Singaporean government. We have approximately 160 staff and scientists who conduct fundamental research in Earth system science, so looking at earthquakes, volcanoes, tsunamis, but in particular climate change. And the aim of this research centre of excellence is for a safer and sustainable society in Southeast Asia. So I'm going to talk today about how sea level rises in the past, present and future are linked between the Arctic and Singapore. Next slide, please. So sea level, despite its name, is a far from flat planar surface. And this is because there are a variety of processes that influence sea level on local, regional and global scales. On the left-hand side of this figure, we see local processes such as groundwater withdrawal. If you remove water for industrial, agriculture, commercial uses, it subsides the ground, amplifying the effect of sea level rise. Another local process is sediment compaction. So rivers deliver huge volumes of sediment to our deltas. They compact the ground, amplifying sea level rise. We then have a whole host of regional factors, atmosphere, ocean dynamics, tectonics. Here in Southeast Asia, we are a geological hotspot for tectonics, and we can have vertical land motion, which amplifies or reduces the influence of sea level rise, both during and between earthquakes. When we get more to the high latitudes, we're going to have other processes that influence sea level. I'm going to spend a little bit of time on that in a couple of slides, and they are glacial-isostatic adjustment and the static equilibrium. At the global scale, we have two dominant mechanisms. Next slide, please. So we have two animations that hopefully will show here, and they are doing. In the bottom left diagram, we see the issue of a volume change. So when we increase our atmospheric temperatures through the greenhouse gas effect, those atmospheric temperatures are transferred into the top few hundred meters of our oceans. When you increase ocean temperatures, they occupy a greater volume and sea level goes up. We also have a mass problem. So we have land-based ice in glaciers, ice caps and ice sheets. You increase your atmosphere and ocean temperatures, the ice melts, it's transferred into our ocean basins and sea level goes up. Now, when we think of the sources of this land-based ice, there are two large sources in Greenland and Antarctica. So Greenland has enough water within it that if it was to all melt, it would cause global sea levels to go up by around 7 meters. But it is Antarctica that worries the scientific community because this is a colossal ice sheet. It has a surface area approximate to Australia. It's 4 kilometers thick, and it has enough water within it to raise global sea levels a colossal 60 meters. So combined, you're looking at nearly 70 meters of land-based ice, and therefore you only need to melt a small percentage of this to have catastrophic impacts on our coastlines. Next slide, please. So these global mean processes of a change in mass or in volume can be amplified by regional processes. This process shown here is known as glacial-isostatic adjustment, and it is the ongoing, i.e. it still exists today, movement of the land surface from extinct ice sheets that dominated the Northern Hemisphere 20,000 years ago. So in areas such as Hudson Bay in Canada, or Oslo in Norway, they were under large ice sheets 20,000 years ago, and therefore the solid earth was depressed. Those ice sheets melted, and now the land is uplifting, diminishing the impact of sea level rise. Conversely, at the margins of those ice sheets, so many of the shorelines of northwestern Europe or the Atlantic and east coast of the United States were on a forebulge 20,000 years ago, uplifted. Since 20,000 years ago, they have been subsiding, amplifying the effect of sea level rise. On the right-hand diagram is a model that we've produced at the Earth Observatory, which shows the current contribution of this process to sea level rise. Now, the areas in red, such as the Atlantic coast of the US, are subsiding at around 2 millimeters per year, adding on to the ocean level rises. Whereas in areas around Hudson Bay, areas around northwestern Europe and Norway are uplifting at rates greater than 3 millimeters per year. Next slide, please. The next process is perhaps even more complex or counterintuitive to explain. And this is a static equilibrium process. And this is the redistribution of mass on our planet because of changes in our ice sheets and our oceans. So these ice sheets are a colossal mass. So when they're at their maximum extent, the water is drawn towards them. As the ice sheets melt, the water retreats from them. So the gravitational signal will result in a sea level fall near a shrinking ice sheet and a sea level rise that's greater than the global average at regions distal from that ice sheet. So on the left-hand side of this diagram, again, we have two models produced by the Earth Observatory looking at the spatial fingerprint if you had a 1 meter contribution from Greenland or a 1 meter contribution from West Antarctica. If we just look at the Greenland example, so if Greenland contributes 1 meter of sea level into our global oceans, counterintuitively, the coastlines of Greenland and much of the Arctic Circle would receive a net sea level of fall of between 20 and 40 centimetres. Conversely, in the southern oceans or here in Singapore, they would receive 1.2 metres, 20% greater than the global average. Next slide, please. So let's first of all look at the past. So on the left-hand side, we have a polar projection of how the ice sheets are changed every 2,000 years. So you can see these large ice sheets in North America and Northwestern Europe. And since 20,000 years ago, they retreat. They don't retreat in a linear manner. They have thresholds that they cross and they start to collapse. So 20,000 years ago, those colossal ice sheets contained huge amounts of our ocean water. And therefore, 20,000 years ago, sea levels were 120 meters below present. What was the effect in the tropics? Well, on the right-hand side, we have animations that we've created here at the Earth Observatory of the changing geographies of Southeast Asia. So between 20 and around 14,000 years ago, because the ice sheets locked up so much water, here in Singapore, you were part of a huge continental landmass called Sunderland. And you could simply walk from Singapore to Sumatra, to Peninsular Malaysia, through to Borneo, and on land bridges all the way over to the Philippines. But as sea level rose, particularly at 14,000 years ago, when there was a meltwater pulse, these land bridges were broken. Next slide, please. So we can take those animations, and we have an animation in the top right just showing, again, the demise of the Northern Hemisphere ice sheets. And we can have graphics that show how sea level has changed underneath the ice sheet, at the margins of these ice sheets, or distal from the ice sheets. And these are 3 locations that I've worked upon. In my PhD and postdoc, I did my work in Scotland. So we showed that over the last 16,000 years, that's your x-axis, sea level has fallen approximately 40 meters because the land has been uplifting, outpacing the ocean level rises. Conversely, in New York City, that's where I did a lot of my professor work before I came to Singapore. Here we have had around a 30-meter rise in the last 10,000 years, because here we've got the oceans rising and the land sinking. And then we have Manila in the Philippines, some work that we've recently done at the Earth Observatory of Singapore. This region isn't particularly influenced by land level changes from glacial ice static adjustment. It does have the impact of the static equilibrium from the melting of those Northern Hemisphere ice sheets. And here we show a fast rise in sea level from around minus 40 meters 12,000 years ago to sort of stable periods of sea level around 6,000 to 7,000 years. And then over the last 6,000 to 7,000 years, sea level's been remarkably stable. Next slide, please. So the changes in sea level in the past control the sea level changes of the present. So what we have here are tide gauge records. So tide gauge records reconstruct sea level over the instrumental period of the 20th century where there are records. So tide gauges, they record high and low water in a day, the average of which is the average sea level in that day. You can build up measurements, and that gives you time series of the year, and you can stretch it back decades or perhaps centuries. So in Oslo, Norway, the tide gauge there shows a fall in sea level of some 30 to 40 centimeters over the last 80 or so years. That's recording a sea level fall of around 3 millimeters per year. Our global oceans are going up at 2 millimeters per year, but the land is outpacing it. So Norway has not had a problem of increased flooding. It has a problem of shorelines expanding and a decrease in flooding. New York City. New York City is on that forebulge from the last glacial maximum and is subsiding. And that is the reason why we get around 50 centimeters of sea level rise over the last 150 or so years, a rate of rise of 4 millimeters per year, twice the global average. We have Singapore on the right-hand side. One of the problems with instrumental records is that they're unevenly distributed. The the vast majority of long-term instrumental records are located in northwestern Europe, such as Norway, or North America, such as New York City. In Singapore, our measurements only really go back to the 1970s. That causes problems when you want to try and calibrate models of the future. But if we look at the records since the 1970s, they're doing around 3 millimeters per year, which is bang on the global average over the time period from 1970 to 2017. They're the data we have there. They're the time length of the available data. Next slide, please. Okay, so now let's look at the future. Okay, so we've understood, or hopefully we've understood, that in Oslo, you've got land uplift, which is diminishing the impact of sea level rise. So what I'm going to show you here is a couple of animations. So one goes from 2010 out to 2050. The other goes from 2010, goes all the way out to the end of the century. So the model that we're using is a model from one of my friends, Robert Kopp, and this model includes dynamic ice in Greenland and Antarctica. So it's invoking mechanisms in this century that will promote the destabilization of those ice sheets. We're going to look at 2 emission scenarios. RCP 2.6, that's the IPCC's low emission scenario, sort of akin to the Paris Agreement, and then RCP 8.5, high emission, sort of business as usual. So if you could click, please, Krista. So we're looking out at the 50th percentile here, the median. In the boxes, we have some ranges, okay? So if we look at the 2050, we can see that there are 2 conclusions from that. One, that there is not much difference between a high and a low emission future, because the impact of not meeting the Paris Agreement is felt in the second half of the 21st century. In this first half, it's all local processes that dominate. And if we look at the median, we're getting between 7 and a fall in sea level under a low emission. So sea level rise is not going to be a problem, because the increase in ocean levels is being balanced out by the changes in land level. However, when you go to the latter part of the 21st century, we now have a distinct difference between a high and a low emission future. And of all the variables of climate, it is sea level that clearly illustrates the importance of maintaining the Paris Agreement, because sea level incorporates what the atmosphere and the oceans are doing. So under a low emission future, as you stretch out, median percentile is no net change. The ocean level and the land level equal themselves out. It's quite amazing that this occurs in Norway. We did these projections earlier this week for this presentation. But on the high emission, you're getting 92 centimetres. And what I would say about that is that I don't believe that there is a single engineer, a single social scientist, a single coastal scientist that knows what will happen to a coastline when you've had 20,000 years of sea level fall, but sometime in 20 years, it flips sign to a rise. Next slide, please. So now we'll look at Singapore. Again, exactly the same. First out to 2050, then to the end of the century, low and high emission. Could you click again, please, Krista? Okay, so if we look out to 2050, again, low and high emission are very similar, but we have none of the mitigating factors of land uplift. So we get somewhere between 20 and 28 centimetres of rise. But when we go out to 2100, we're getting exceedingly dangerous values here. So under a low emission, it's 51 centimetres. And so if we think about rates, that would mean that at the end of this century, you're doing about 6 or 7 millimetres per year. And if you had a look at the tide gauges today in Marina Bay, they're doing around 4 millimetres per year. So that's not such a significant increase in rate. And therefore, I would expect that we're able to adapt our coastlines. And certainly our coastal ecosystems can keep pace with that rate of rise. But a 1.5 metre rise is existential. And if we look at the boxes, the 95th percentile is 2.63 meters. Even at the median at 1.5 means that somewhere around 2080, we're doing rates of 30 to 40 millimeters per year. And there isn't because I've done some work on this, I wrote a paper in Science this summer, there isn't a coastal ecosystem around the world that can withstand that. I mean, just to sort of get that over to you, there isn't a coastal ecosystem that can survive that. So all your corals disappear, they can't keep pace. All your mangroves get submerged and lost. All your wetlands get submerged and lost. And we want to think about the knock-on effects about that on the coastal ecosystem. Okay, and I'll just wrap this up with the next slide. So we have been funded by the sea level government to do studies on sea level change. You may have seen the news that came out this morning in that there's been the start of a national sea level programme, and we've got the only 2 grants from this programme. And our aim of our work is to try and understand the processes that drive sea level at the global, regional and local scale, and also think about sea level extremes. Once we have that, we're able to refine the projections that I showed you previously to try and understand their uncertainties. And then the aim of this project is then to look at risk-based methodologies for coastal adaptation, thinking about planning, education and communication. And the Earth Observatory of Singapore, not only in this sea level project, but in all of our projects, the aim is to foster a homegrown workforce. So we train PhD students and we train researchers here from Singapore and elsewhere in Southeast Asia to try and provide the knowledge that will be needed in future generations to respond to this crisis. So thank you very much, Per Krista, great work, that went smoothly. I'm sorry I couldn't link it earlier.
Robert, you're muted.
Thank you, Ben. I'd like to now move to Dr. Kristin Richter, who is a research scientist with the Norwegian Research Center in Bergen, Norway. She specializes in glaciers and sea level rise. So, Kristin, all yours.
Thank you. Yes, thank you, Bob, and thank you, Ben, for a really nice introduction. I was planning to give a short overview over sea level research we do at NORCE. So NORCE is the Norwegian Research Center, which is another large independent research organization in Norway. So I don't have so much time, so I will quickly go through our main activities just to give a brief overview and give an idea over the work that we do. So we focus at NORCE quite a bit on ice sheets, and I will give 2 examples. But we also look at regional sea level changes, both in Norway, but also in other parts of the world. Ben already gave a nice introduction about the importance of ice sheets. So they have a potential to rise sea level by about 70 meters, so they are really important. And one of our main projects, TIPEX, Tipping Points in Antarctic Climate Components, addresses the Antarctic ice sheet. So the goal of TIPEX is to assess the possibility of a large and sudden increase in sea level due to abrupt changes in Antarctica. So what are these abrupt changes? What can they be? So in Antarctica, Antarctica is covered by ice. We just heard this from Ben. And the ice flows from the interior of the ice sheets towards its edges, where it starts floating and meets the ocean. So it forms ice shelves. And these ice shelves, they are in direct contact with seawater. So ice meets the ocean, so to say. And recently, observations show that this seawater below the ice shelf has been warming. So this would be one tipping point. That means the ocean or the seawater below the shelf can tip from a cold or current cold state into a warm state. And if this happens, actually the ice shelf can start to melt from below. Not just from above, but also from below, because it is in contact with warmer water. And these ice shelves, they are very important for the ice sheet because they buttress or they stabilize the ice sheet. So if they thin or even disappear, this could actually lead to a retreat, to an uncontrollable retreat of the ice sheet. So more ice flotation and rises sea level. So this would be the second tipping point, the Antarctic ice sheet tipping points. And this project aims to really assess how fast this could happen, how much ice could be lost to the ocean, and how likely this is. So this is not a direct projection, it's more an assessment of what is possible. But we have another project, or not a project, a colleague who just recently joined us, Heiko Gölzer. He's a key person in ISMIP. So ISMIP is the ice sheet intercomparison project. And the aim of ISMIP is to estimate the future sea level contributions from Greenland and Antarctica, along with associated uncertainties. So this ISMIP is quite a big effort. It's the first time that really the ice sheet contribution to future sea level rise has been estimated systematically across the entire ice sheet modeling community. So this is really something that is rather new. And with our new colleague, we want to continue to build on this work. And we also plan to couple an ice sheet model to an Earth system model, which is also something that is popping up everywhere now, but it has not been done before. I'd just like to give a quick example about the results of first results of this project, and this is the future contribution of the Greenland ice sheet to global sea level. These projections are based on CMIP 5, so on Climate Model Intercomparison Project 5 forcing. So that means we have different ice sheet models that are driven with the same forcing. They did this for two different scenarios. The blue curve here is the low emission scenario. Ben already mentioned these scenarios, and this red shading gives the high emission scenario. And you can see within the 21st century, there's quite a bit different. There are some differences. So for the low emission scenario, we have about 3 centimeters contribution from Greenland, but at the end of the century, this is stabilizing. So you can kind of stop, or it indicates that this melting can be stopped by the end of the century. Whereas for the high emission scenario, we have big uncertainties, but the contribution is about 9 centimeters and it is accelerating. So now we just learned that for Norway, we don't really care because we will not notice anything about that, but this will be felt over proportionally large in Singapore. So this is really important to quantify this and to get this right. Yeah, so this is what we do on ice sheets, or these are two examples that we do on ice sheets. And this is related to global mean sea level changes, but we also look we are also very interested in regional sea level changes, also on smaller spatial scales and on shorter time scales. So in that respect, we do compare observed sea level changes with modeled or simulated sea level changes. And this gives us the opportunity to partition between internal variability and forced signal. And this is roughly, we can say, between natural variability and human-made sea level rise. And by comparing models and observations, we can reduce uncertainties by really selecting those models that reproduce the observations best. And we can also try to detect a human signal and attribute, or to detect a signal and attribute it to either natural causes or anthropogenic emissions. And I just want to show one example. This is from the northern North Atlantic, so the seas around Norway. And this is the sea level trend over this 20-year period as measured with altimetry. So this is a relatively short period. And you can see large regional variability. So you can see higher trends south of Greenland and lower trends in the Nordic seas between Norway and Greenland. But the trends are mostly positive. So sea level is rising over this 20-year period. And using now climate models and comparing them with the observations, we were able to separate these pattern into a forced signal and into internal variability. And so this is how this looks like. We have the upper panel shows the forced signal, the lower panel shows the internal variability. So you can see that the forced, so more or less the anthropogenic signal, does not really is not really similar to the observed pattern, but it has it consists of a mean rise over this area. So sea level is rising, while the internal variability really resembles the observed pattern rather well. And if we combine these two signals, the forced signal and the internal signal, we get the total simulated signal. And you can see it's not perfect, but it agrees very, very well with the observations. So this is an exercise we did for the North Atlantic, but this can be done and should be also done for actually every region in the world. And here we use 20 climate models, but by really selecting the models that reproduce the observations best, we can also narrow down the uncertainty by only using these models to project future sea level rise. So this does tell us something about the models, but it doesn't really tell us where this signal comes from. And this is something that is addressed by another project, TikTok. That's the transient tracer-based investigation of circulation and thermal ocean change. And one of the goals of this project is to quantify and explain the evolution of ocean temperature change to improve predicted regional sea level change. So what is being done in TikTok is that the total warming in the ocean is separated into a redistributed part, so heat that is redistributed largely due to circulation changes, and an added heat part. So that is the heat that is really the net heat that is added to the ocean, that is the direct response to increased radiative forcing. So you could also say that the redistributed part is kind of due to natural variability, roughly, and the added heat is the heat that is added due to anthropogenic emissions, roughly. And I also would quickly like to show one example. So this is the change in ocean heat content. So the heat that is more or less, the heat content, how it changed between these 2 6-year periods. And you can see there are patches, roughly patches of warming, the red areas, and patches of cooling. And you can also see there's large variability globally around Singapore, but also around the Nordic seas and Norway, which is a bit more difficult to see. So what they did now is they separated these total heat content change, which is from observations, into a redistributed part and an added part. And this is how it looks like. And remember, this is a really short period, the difference between 2 6-year periods. And you can see that regionally, the change in heat content or in heat is really heavily governed, impacted by circulation changes. So the amplitude is quite big. This is the upper panel on the right. The amplitude is quite big, and you can see big regional changes. And you can also, maybe you cannot see this very well, but this is also rather uncertain. So there's stippled areas and they are uncertain, and that's because the variability is just so big. And in the lower panel, you can see the added heat, and you can see the amplitude is much smaller, but it is more coherent. So it's really evenly, heat in the ocean is evenly increasing across the world's ocean. And this suggests that the ocean is really continuously or persistently taking up heat over this period. So by doing this, this is really similar to the previous slides I showed you. But this is really looking at the mechanisms that are behind regional sea level changes. And by understanding this, we can then really improve sea level projections and reduce uncertainties. So what I presented now is these key research areas. They are mostly we are done globally. But it is really important also for Norway to do local projections. So at NORCE, we have a high emphasis of co-production, where we work with stakeholders. And Ben was now explaining that actually Norway, that the land uplift in Norway outpaces the sea level rise until now, and that we do not have problems with flooding. And it is partly true in eastern Norway around Oslo, but the west coast also experiences land uplift, but not as strong. So here you can see a picture of flooding in Bergen early this year. And actually earlier this year, we had 2 events of flooding in Bergen that are actually only expected every 30 or 40 years. So Bergen was flooded twice this year, and due to the inferred from the historical record, this is actually only supposed to happen once every 40 or 50 years. So we do have problems with more increased flooding also in Norway, and this will at the west coast, and this will just, the problem will be bigger as time goes by, as also Ben showed. So we do work with stakeholders. We try to disseminate our knowledge to stakeholders to really meet this problem and to find good solutions also in Norway. And I think that is what I had to say. Yes.
Okay, thank you very much, Kristin. I think we'll move quickly into, we only have about 10 minutes left, so we'd like to have some time for questions. I'd like to call on our third speaker. We're moving now to the impact on law of the sea and ocean law with my boss, Dr. Nilufer Oral. Are you there, Nilufer?
Thank you, Bob. I can only be your acolyte, never your boss. You're the guru of law of the sea. Thank you so much. I have to say I'm really happy to be following these two very important and eminent scientists on the physical aspects and of sea level rise and ice melt. And I have to say, I think governments really have to understand the science, because I'm going to explain very briefly in the time we have the legal consequences, which also are consequences for people's livelihoods, millions of people's livelihoods. So I have, let's see if I'm successful in doing, can you see this? Yes? Can you see my slide?
We can.
Okay, excellent. All right, so I'm going to talk about the legal aspects of sea level rise from the law of the sea perspective, and a little bit about adaptation of the law. But sea level rise is happening, and I think Professor Horton explained kind of this. It seems counterintuitive, but as the ice melts in the north, the consequences are going to be felt farther away in places such as the South Pacific and obviously in the region we're in, Singapore. So it's happening right now, where people are already being impacted, particularly small island developing states, the Pacific, and also low-lying coastal areas. Why is this important from the legal perspective and law of the sea? Very briefly, there are maritime zones, and these maritime zones are very important. For example, territorial sea, exclusive economic zone, continental shelf. These are areas over which the state exercises sovereignty rights, or in the case of the territorial sea, sovereignty. And that means that they have control to exploit, use, manage, regulate the resources that come with it. The problem is that these maritime zones are built upon very ephemeral features, such as little rocks or islands along the coastline, or it could be the coastline, which is low-lying, starts regressing. And because these zones are built on what we call baselines, with sea level rise, they could disappear. And then the problem is, well, what happens? Do you then have to change your maritime zone? You lose that maritime zone that was established through a maritime boundary. Another issue we have concerns islands. And islands under the law of the sea, they meet certain criteria I'll talk about a little bit later, are entitled to all these maritime zones, including the exclusive economic zone, which is very important in continental shelf. But could become rocks because of sea level rise, in which case they could lose their entitlements to an exclusive economic zone that goes up to 200 nautical miles, or the continental shelf. And again, we're talking about the very valuable natural resources that come with these maritime zones. So the question then is, from the legal perspective, if because of sea level rise, certain states, and particularly often it's those that are most vulnerable and perhaps have the least to do with causing climate change and sea level rise, if they lose or there's a diminishment in their entitlements because maritime zones will decrease or be completely lost, can they be preserved? And this is a big challenge right now for international law that we're starting to look at within the UN system. So it's a question of how to preserve these entitlements. And that's the question that I have been looking at, is whether we can see law, international law in particular, as part of the adaptation to these consequences. Again, another legal consequence, archipelagos. Boy, this was a big issue for decades. Archipelago states for a long time tried to get recognition of being an archipelagic state. And so what that means is that under the Law of the Sea Convention, they were given that right, and that allows them to draw, again, a baseline that around the outermost lying islands and also reefs. And so then that allows them to enclose an area that perhaps once was high seas. But there's a very complicated formula. I'm not going to go into the details on that, but I'll just say this: sea level rise, if it results in the loss of those outermost islands, 1 or 2, and that changes that formula, that could have very serious consequences for those archipelagic states, because they will possibly lose what are called archipelagic waters and all the legal entitlements that go with that. And frankly, it could also impact, in all cases, relationship with third states. So one of the concerns as well is the impact that this would have on stability, legal certainty, predictability, and basically peaceful relationship among states, in particular neighboring states. I mentioned earlier about islands. So again, the Law of the Sea Convention gives us a definition of an island that's naturally formed, surrounded by water, and is above water at high tide. The problem is that if it's a above high tide feature that cannot sustain human habitation or an economic life of their own, this rock will not be entitled to the exclusive economic zone and continental shelf that a full-fledged island is. But what does that mean? Cannot sustain human habitation. Why is this important for sea level rise? Because we know that sea level rise does impact, for example, water supplies, potable water supplies. The entry of salt water can make an island uninhabitable. It can impact agriculture. Even though it's still territory and above high tide, it may not be habitable anymore. So the question is, once an island, will they lose that status? And again, becoming a rock, devolving into a rock, has huge consequences when many of these island states depend on fisheries, natural resources for their livelihoods, and any loss of that can have really catastrophic impacts. So these are some of the questions that international law has to resolve. And one of the things that are being looked at, one by the International Law Association, and now at the International Law Commission that I'm a member of, is how to preserve stability and preserving maritime entitlements and preserving the agreements, for example, the permanency. So that is why I think we have to look at international law, not just as a set of rules to implement, but also we have to look at it as a flexible adaptation measure, where if the objective is to preserve stability, to preserve legal certainty and predictability and peaceful relations, then part of adaptation measures to sea level rise should not be simply physical measures, such as, building up your coastline, or artificial measures, which we know there has been, there's a history of that, or even, planting mangroves. All these are important, but the law also has to adapt. So I hope I was able to give a very brief overview of what's a very complicated situation, but this is a little bit of legal consequences. So thank you so much for this opportunity.
Thank you very much, Nilufer. Tori has kindly said our 45 minutes is up, but Tori has kindly said we could take a few extra minutes. So if there's a couple of questions, we'd be happy to field them. You could either raise your hand or turn on your microphone and simply ask a question if you like, or make a comment. If not, Ben, are you still there? I'd like to ask one question of you. I know
yeah,
you've done.
Still here. I'm still here.
I know you've done some work on this. From what you've observed so far, which areas of Southeast Asia are the most at risk from sea level rise?
Well, my answer to that would be you'd have to define the time scale.
Well, let's say in the next 20 years.
Okay, so as I said in my presentation, it's all about the local in the next 20 to 30 years. I mean, I think, the last presenter stated it perfectly that, you have to, before you, let's say, waste taxpayers' dollars on adaptation processes, you have to follow the science. And so if we're looking at adaptation processes to coastal infrastructure over the next 20 to 30 years, we have to do the science on local sea level projections. And that really is the state of the art. That's why the Earth Observatory of Singapore is very interested in working with our Norwegian counterparts, because they have some of the state of the art models on ocean dynamics. And as we've seen from one of the other presentations about the ice sheets integrating with Earth system processes. But if you want to look, what I feel, it's in the next 20 to 30 years, it's the regions that have significant groundwater withdrawal. So there are high profile ones such as Jakarta. So Jakarta has been removing groundwater withdrawal, that here at the Earth Observatory of Singapore, we use what are called INSAR satellites. And these INSAR satellites measure the surface of the ground at millimeter resolution. And these satellites we use to illustrate that areas of Jakarta are sinking at somewhere between 15 and 20 centimeters per year. Remember when I said that what the global average is of sea level is somewhere right now at around 4 millimeters per year. We're talking orders of magnitude greater what Jakarta's doing. And then there are other cities that have similar problems. Parts of Manila are also sinking. We've done some INSAR satellites there that are looking at around 10 to 15 centimeters per year. But this really hasn't been studied greatly. We have a program at the Earth Observatory right now to look at variable sinking rates on the largest 10 cities in the world. But it's not, as you can imagine, it's not a simple process. But we hope we'll have a document early next year which will look at this. But in Southeast Asia, Jakarta is the real hotspot. Manila, Bangkok, many of the regions that have groundwater withdrawal or sediment compaction, they're the real hotspots.
Okay. Any question or comment from other speakers? Kristin, do you have any questions you'd like to ask? Christopher, you have a question. I see a hand.
Yes, I think it goes to both Ben and to Kristin. The projections, Ben, that you showed, the RCP 2.6 or 8x5 is it looks of course very, very severe. These are based on the projection of the continuous CO2 emission and the concentration rise of CO2 in the atmosphere, I assume. Would it be interesting similar kind of simulations where measures that are being taken or could be taken. For example, Europe is moving into a zero emission by 2050. We have enhanced CCS, maybe negative sinks and things. Kind of also to try to make a bit possible more positive or more optimistic projections. So basically doing simulations, what happened, what will the curve look like if we implement these and these and these measures by this and this time. Have you done any of those calculations and see how that influences the rise?
Well, maybe I could answer first and then Kristin could follow up. Well, I mean, that's really the aims and objectives of the current IPCC. So the sixth assessment report is currently doing a variety of different simulations of greenhouse gas emissions and their associated radiative forcing. So I'm part of that. But the key about carbon dioxide in the atmosphere is it stays in the atmosphere for hundreds of years. So changes that you make now are really not felt until the latter part of the century. The sea level rise we have now, we're locked in. The sea level rise that we have over the next 20 or 30 years, doesn't matter what you do with emission scenarios, it's still going to happen because we're responding to the CO2 emissions that started in the 1880s. So we're always going to have sea level changes because we've changed the atmosphere and then we have the changes in the ice sheets and the ice sheets respond slowly. The key about sea level is looking at the RCP 2.6 because that is the Paris Agreement. And if you delve into the details of the Paris Agreement, it's all about keeping temperatures 1.5 or 2 degrees C warmer than the pre-industrial temperatures. And we've already had 1 degree C rise. So we've only got half a degree or 1 degree wiggle room. Now, why 2 degrees C? Well, that's because geologically, we know that if you go above 2 degrees C, the Antarctic ice sheet disintegrates because we can go back to previous warm periods in the Earth's climate. So the last interglacial, 120,000 years ago, temperatures were 2 to 3 degrees above today. What was sea level? 4 to 7 meters higher. Go back to the Pliocene, 3.3 million years ago. What were temperatures? 3 to 4 degrees C warmer than today. What were sea levels? 10 to 20 meters higher. That's why you keep to the Paris Agreement. So you can do all the simulations that you like. The only simulation that you really need to account for is that 2 degrees C threshold. So the IPCC do this. They look at 1 degree C world, 2 degrees C world, 3, 4, 5, and 6. And then there are a whole host of RCP measures. But really, my feeling about it is it's a threshold. You've got to keep to the Paris Agreement. That's the only future we want. Don't want anything else. But Kristin may know some more intrinsic details regarding this.
Okay, Kristin, and then we'll move to the next session.
Yeah, just briefly. No, I generally agree with Ben. So we are already committed to a certain sea level rise just because glaciers and ice sheets, they are out of their equilibrium. So this is going to happen. Irrespective of changes or of stopping emissions or whatever. So we are committed to a certain sea level rise. What we also do, some of our colleagues, they look at so-called overshoot scenarios. So what are the impacts of maybe going above 2 degrees for a certain period of time and then starting carbon capturing, taking CO2 out of the atmosphere and go below towards 1.5. So we are looking at these kind of scenarios as well. Because as it seems now, we are on track to a temperature change larger than 2 degrees. So yeah, this is something we do, but we only started doing this. Yeah.
Okay, thank you very much. I'd like to thank all three speakers for very interesting presentations. And it's now time to turn it over to my friend, Tori Hendrickson. Tori.
Thank you, Bob, and thanks to the presenters. Really interesting. We are now in the second part of the webinar, and the title is Ocean Politics, Global Challenges, Biodiversity and Marine Environments in the Arctic. And the Arctic were the topic of the previous part, and the Arctic is also something that have connected Singapore and Tromsø for a while. We have had cooperation on several projects for instance, on shipping, because the topic here in the second part also relates to climate change and the opening of the Arctic. And the first speaker is Vito de Lucia. He's a colleague of mine at the Norwegian Center for the Law of the Sea here in Tromsø, an expert on particular international environmental law. And after that, we have comments from Ms. Youna Lyons from Singapore, the Center of International Law, also an expert on international environmental law. So I give the floor to Vito.
All right. Thank you, Tore, and thank you also, Kristin, for organizing this. I'm very happy to be here today. I will talk today about and when I speak and introduce the topic, I'll try to share my screen. Okay, I don't manage to multitask. Okay, there it is. So I will talk about a global process that is ongoing at the moment under the aegis of the United Nations to adopt a new treaty on marine biodiversity.
We don't see your screen, Vito.
No, I'm getting to it.
All right, sorry.
Okay, now it should come up. It's loading. Yes, and then I will relate this process to the governance of Arctic biodiversity and outline a couple of ways in which this may have important impacts in the Arctic. So the treaty, the treaty is seeking to set out a legal framework for the conservation and sustainable use of marine biodiversity in areas beyond national jurisdiction. So that will then include, and here I use the reference to the maritime zones that Nilufer has shown. It will include, geographically speaking, the high seas. That is all the water sea areas beyond national jurisdiction, so beyond the territorial sea or exclusive economic zone, and then the seabed beyond the limits of national jurisdiction. Here you see a map of the globe, and you will see the dark blue areas are the high seas, and they are quite a large area. And they cover, in fact, about 50% of the surface area of the globe, and by volume, they represent a much larger percent. They also are very rich in unique biodiversity, and they contain many rare and fragile ecosystems. However, the legal framework today, which is primarily set by the Law of the Sea Convention, including also a number of other legal instruments which have either regional sectoral competence, but also by the Convention on Biological Diversity, create a somewhat fragmented and less than comprehensive legal framework, so that there are a number of gaps for the conservation of biological diversity. The UNCLOS is a framework convention, so in many respects doesn't have a detailed rules on a number of topics that we will see in a minute. And then all these global sectoral or regional conventions again have limited competence, either geographically or in terms of subject matter. And the Convention on Biological Diversity, which is also a global treaty, has limited competence in relation to biodiversity in areas beyond national jurisdiction. And in addition to that, there's great regional variation in both the existence and the type of legal frameworks in place by different organizations. So there is a number of legal gaps that have been identified over the years, and this is a process that started in earnest in early 2000. There is, for example, a lack of a comprehensive legal basis to establish marine protected areas in areas beyond national jurisdiction. you would have different regional organizations or sectoral measures that can be adopted, but again, there is a lack of a comprehensive legal basis. There is no global rules for environmental impact assessment. The Law of the Sea Convention contains, of course, some rules, but they're not deemed to be sufficient also in terms of detailing the content of environmental impact assessment. The same goes for international environmental law, where there is a general obligation to carry out one, but the contents are left to discretion of individual states. There is also a question related to marine genetic resources. I will focus in a few minutes on the question of areas which is more immediately relevant for the topic of this session. But anyway, so on this basis, on the basis of recognition, the lack of legal basis, a process was initiated towards trying to articulate first some elements and then a treaty to address these legal gaps. So this process was started in 2004 with the establishment of a ad hoc working group to study these questions. That process led to recommendations that were submitted to United Nations General Assembly to launch a process on the basis of 4 topics, and again were marine protected areas, or rather area-based management measures, including marine protected areas, marine genetic resources, including the sharing of the benefits arising from their utilization, environmental impact assessments, and then capacity building and the transfer of marine technology. In 2015, the United Nations General Assembly launched a process first through establishing a preparatory committee that would develop draft elements for a treaty, and then in 2017, a formal intergovernmental conference was launched with a purpose again, of adopting such treaty. At the moment, the status of the negotiations are on a COVID pause, if one can put it that way. The last scheduled session, the 4th, was to take place in March 2020, but that couldn't happen. At the moment, there is an intersessional session ongoing over the internet, and the date for the next actual session, so the next conference, it's still unknown at this stage. So the mandate of this process was again to adopt a treaty with a couple of specific limitation. One is that this new treaty, which will be an implementing agreement of the Law of the Sea Convention, has to be naturally consistent with the provisions established in the convention. And the other one, discuss a little bit later during this presentation, is that the new treaty should not undermine relevant instruments, frameworks, and bodies. And as I said, I will get back to the meaning of this limitation in relation to the Arctic governance. So this was maybe a long introduction to the global process, but then within this global process, now I'm going to focus on the Arctic governance and how this process is relevant. And it is relevant, and you will see from the map here, to the extent that an important portion of the Central Arctic Ocean lies in areas beyond national jurisdiction. And while a good part of that area is covered by ice, there is an increased melting on this sea ice, and due to climatic changes that we have heard much about in the previous session, and there is an increased number of activities that have become possible or are already taking place in the Arctic because of the melting of sea ice. And on top of that, the Arctic is a very vulnerable environmentally area. It's rich in biodiversity and also unique biodiversity because of special conditions. So it is important to understand how this new global treaty may impact the governance of Arctic biodiversity and Arctic marine environment. To do that, first is important to see how the Arctic as well as or in the Arctic as well, there is a complex web of global and regional instruments that apply sectorally or and then that regulate many aspects of human activities in the Arctic. However, there is also in the Arctic jurisdictional fragmentation, material scope fragmentation, and there is there's a lack of comprehensive regional regime. The one body that that has taken up the role of coordinating biodiversity governance in the Arctic and cooperation between the Arctic states is the Arctic Council, and this is what I'm going to focus on the last part of the presentation. Was established in 1996 and is a high-level forum that gathers 8 members, and from which are Arctic coastal states, and that will be Russia, Canada, the United States, Norway, and Denmark with respect to Greenland. It also has permanent members, indigenous people organizations, and then there's a number of observer states. But the aim is cooperation coordination on Arctic issues with particular reference to the marine environment. And most of its work takes place through a number of working groups, some of which are particularly relevant for our purposes, and that is the protection of Arctic marine environment working group. Especially, and so it's a forum that for the study and discussion of environmental matters, and it produces a number of reports. It elaborates recommendations, and in that respect has an important role of shaping. But it doesn't have, because of a lack of legal personality and formal legal competence, direct policy making. Okay. So what are the impacts of a BBNJ treaty? One aspect that where it could fill an important role is by establishing, as that was one I was saying, the legal competence to adopt marine protected areas. For example, the Arctic Council has done incredible work in relation to setting out a framework for a pan-Arctic network of marine protected areas, but because of its lack of formal legal competence, it can only recommend to coastal states that within their jurisdiction they adopt marine protected areas within the context of this framework, and it can also only recommend international organizations that may have competence in areas beyond national jurisdiction to do the same. However, because there is no regional body with formal competence to adopt marine protected areas cross-sectorally in the Arctic, then this part of the report can never be implemented. But if the new treaty is adopted, that could fill this gap and therefore allow the implementation of such recommendations as the Arctic Council through its working group has produced. However, there is also a question of what the role of the Arctic Council would be in a new global treaty with legal competence to regulate Arctic activities. And again, here we go back to the question of how the new treaty will regulate its relationship with other instruments and bodies. And we have seen that there was this general mandate that it should not undermine existing relevant instruments and bodies. But a question that is at the moment unclear, and that we are doing some research on, is whether the Arctic Council could be one such body, given that it doesn't have legal personality. And here you have a number of questions to address. One is whether the Arctic Council is a body for the purpose of these provisions in the new treaty, which of course at the moment remain only draft provisions. And then the second question is whether it's a relevant body. And the question is then how, and depending on how you answer the question, it's then the impact is how the Arctic Council would be integrated into a world where there is a new global agreement, which will have mandate, both in terms of regulatory mandate, but also in terms of generation of scientific basis upon which to enact regulation. So, and here I think that perhaps the role of the Arctic Council would be to try and be integrated into as a scientific advisory body in the global framework, which is at the moment still being articulated and negotiated, and especially provide its valuable input for the development of a biodiversity governance framework that would recognize the need to integrate all activities and all impacts within a singular framework, and which is normally referred to as an ecosystem approach, where the Arctic Council has done significant work. Another side question is it's also related to the specific positions, and with this I will conclude, of the coastal Arctic state and the coastal states in the Arctic, which have always maintained the wish to operate as steward of the Arctic, and have considered always that the Low the Sea Convention is a sufficient framework, and then the rest can be handled by the Arctic Council. And however, with the adoption of a new treaty, which would have direct competence in the Arctic or in the marine Arctic beyond national jurisdiction, there could be some impact on also the role that the Arctic Council has had as a cooperative framework in both in times and spaces where in other matters cooperation hasn't been so easy. So with this I conclude, and I'm happy to take questions, and I tried to condense, hopefully in a clear manner, a very large topic. So thank you all, and thank you, Thor.
Thank you, Vito. I think we just proceed to Youna, and then we take questions and comments afterwards. So Youna, you're on next.
Well, good morning, afternoon to all. Thank you for inviting and giving me the opportunity to share a bit of our work. So let me also share now my slides. There are not many of them. Yes, is that now visible to everyone?
It's coming. There it is.
Well, wonderful. And thank you, Vito, for this introduction on the BBNJ and the Arctic. I did consider doing a parallel discussion on the Arctic and the ASEAN, but within the ASEAN, it's not quite clear whether there is any area beyond national jurisdiction, given the dispute in the South China Sea. So made the choice, having comments to make, to steer away from that one, and rather look at what we could learn from the Arctic Ocean. And actually the inspiration, and I have to confess that, came from a work that I'm engaged in with colleagues at NUS, at the Center for International Law. There's 5 of us, and we've been looking at ASEAN law and policy, the development of ASEAN law and policy with respect to the protection of the marine environment, with a bit of a magnifying glass, and looking at it in great details. And so it's quite inspiring and interesting. I started attending meeting at the Arctic Council not so long ago. And so I'm going to provide you maybe food for thought and ideas with a bird's eye view that compares the Arctic Council, the Arctic Ocean issue, and the South China Sea and the ASEAN. So the starting point for all of that is some obvious common features to justify that actually say that it's not such a bad idea to compare them, although at first you would think, oh well, there's the polar seas and that's the tropics. I mean, it has nothing to do, nothing in common. But in fact, so they're both regional seas, although obviously the Arctic Ocean is much larger and is an ocean. It's not a marginal sea like the South China Sea is. They're both semi-enclosed. Both of them have actually members that are not coastal states of the relevant oceans, meaning that the Arctic Council has a number of Arctic states, as 2 Arctic states, and I will go back to that with the map, that are not actually coastal states, strictly speaking, of the Arctic Ocean. And similarly, in the context of the ASEAN, with coastal states, with member states of the ASEAN that are not coastal states of the South China Sea. They both have a fairly small number of coastal states. If you were to compare, for instance, with the Mediterranean Sea, where you have more than 20 coastal states. But despite that, the affairs of the region are actually quite mingled up with the global community that wants to have a say into what is happening in the region for different reasons. They are both subject to serious, deep, long-lasting political tensions and maritime disputes. They're facing an existential climate crisis with vulnerable systems, so sea level rise rather in Southeast Asia, as we've heard, and rather ice melt in the context of the Arctic and the impact that has on the marine environment, etc. They both, despite the very relevant legal point of legal identity of the and legal authority of the Arctic Council versus the ASEAN, they still are focused on political dialogue, and with no delegation of authority to regional bodies. They do favor political dialogues. It's their preferred modus operandi. Now, another important element which Vito alluded on is the fact that they both have several regional institutions with overlapping mandates. That creates a certain dose of confusion and makes sometimes things difficult. And then I put there with a question mark, indigenous population. It's an obvious fact in the context of the Arctic Council, since the indigenous are the original inhabitants of the Arctic Circle. And they also are the one with the greatest knowledge of the marine and coastal environment there. There also are indigenous populations in Southeast Asia, but they are not on the agenda quite in the same way. I'm thinking about the sea nomads that are throughout the region, the Bjelland and the others, and as well as a lot of coastal populations that certainly have been dealing with the marine environment and are in some ways more knowledgeable than the science has yet been able to develop. So now moving a little bit to some geography so that we can situate ourselves, and I can see in the names that are on the participants that there's some people from the north and some people from the region. So if we look first at the Arctic Ocean, this is a snapshot actually a screenshot that I took out of the Google Earth, but which is the view of the Arctic Ocean that you get when you're moving straight north from Singapore. And so starting there, you will see Russia, the coastline along the Arctic Ocean, and then moving towards the east, so the United States with Alaska, along coastlines and very accidental with lots of islands of Canada. then Greenland, and well, Denmark through Greenland, Iceland somewhat outside the main basin of the Arctic Ocean, Norway, and here it's Sweden and Finland that are more looking towards the Baltic Sea than they are really on the Arctic Ocean. This said, as we'll see, looking at the bodies that are looking at the environment and coastal and marine environment, there's another one than PAIM that looks after the marine environment. There's also one that looks at terrestrial Arctic life, fauna and flora. So they're certainly very much involved in Arctic affairs, although they're not a coastal state strictly speaking, which can be relevant in the context of management of the marine environment by coastal states, as the law of the sea suggests that it should happen. So if we now look at the South China Sea, so I'll start in the north with China, and then you go along the coast of Vietnam, within the Gulf of Thailand, which from a marine environmental perspective would be considered as part of the South China Sea, although it's a gulf. But there's no straits between the Gulf of Thailand and the South China Sea. So Cambodia and Thailand are the coastal states there. Laos, landlocked countries, Myanmar, facing the other side, are also members of the ASEAN, but they are not coastal states of the South China Sea. Then you have Malaysia, which is both on the peninsula north of Singapore, but also in Borneo. Indonesia, that has all the southern part, and the islands of Natuna, the tip of the archipelagic sea here, is in the South China Sea. Singapore on the very edge of it, and then Brunei, then Philippines, and the island of Chinese Taipei or Taiwan, which is closing the straits. So we clearly have semi-enclosed seas, as the geography shows, and both the central South China Sea and the central Arctic Ocean have a deep basin area where the claims for extended continental shelf can be found. So now moving to the regional competent organization, let's see, this is really a bird eye view and not very much a legal analysis, more of a policy, who has mandate and who does what, who are the players kind of approach. I didn't mean to be so quick. Okay, so the Arctic Ocean on the left. So we'll start with the Arctic Council. The Arctic Council has a number of states. The 8 states of the Arctic Council are not, only 3 of them are only part of the Arctic Councils. There are other regional organizations, in particular OSPAR, which overlaps with which is partly on the Arctic Ocean, and a great interest of the European Union because of members of the Arctic Council being also members of the European Union that are also involved. So when we look at the landscapes of what is a party to what, so I have underlined the coastal states of the various oceans. And so in the Arctic Council, we have Canada, Russia, and the United States that are not a member of the other entities. OSPAR that overlaps with the Arctic Council, and you have a lot of other countries, including members of the European Union. And you can see how the mandate of the European Union of OSPAR is very different from that of the Arctic Council in terms of legal status of the decision and the fact that they are immediately applicable. And so you end up with a conflict, and in the context of MPAs, you have situations where the OSPAR side of the discussions will say, but we've agreed on a certain number of areas that should be looked at in the context of the Arctic Ocean, but the Arctic Council has not responded to our invitation to make comments to the scientific suggestions that we'd made. So that's not very easy. Now, in the context of the South China Sea, you can see that it's underlined here. We have the 9 coastal states of the South China Sea, but China is not part of the ASEAN. And then some members are not a part of the ASEAN +3, which is an extension of the ASEAN, and some members of the ASEAN are not coastal states of the South China Sea, which, similarly to what might happen in the context of the Arctic and other bodies, doesn't make things particularly easy. But China is actually a member of NOPAP, which for the Northwest Pacific, and the coordinating body for the Sea of East Asia, which are both UNEP regional seas bodies. So which is, and here you get different politics, different influence, also different funding that can be useful in the context of Southeast Asia, but doesn't make for a particular easy context to deal with. So I will leave that the general overview, and I will only introduce it without going to it, that in terms of number of states that are involved in different organizations, it gets even more complex when you start adding activities at sea, such as fisheries, that you can't really talk about the protection of the marine environment without talking about fisheries. And here again, you get a number of other international organizations that overlap with both the South China Sea and the Arctic Oceans and the member states, and have different states that are in the game. So that leads me to just zooming a little bit one step down, and it's the last institutional piece of information before I wrap up. So when you look at the Arctic Council, and when you look at the ASEAN, first you see the same structure of ministerial meeting at higher level. So for the ASEAN, you will see the ASEAN leaders at the top, and then you'll have, in fact, within the ASEAN, because the mandate of the ASEAN is so much wider than in the context of the Arctic, the work is divided into 3 pillars, and we have the socio-cultural community, the political and security community, and the economic communities. The marine environment falls below the socio-cultural communities. But then when you look at the structure of this, you will have your ministerial meeting, and then you'll have the senior officials, and then you get the working group. If you look as a mirror, you look at the Arctic Council, and you see a similar workflow where the senior Arctic officials will delegate to a series of working group. And here we have PAIM, the one that was mentioned also by Vito, which focuses on the protection of the marine environment. But then under PAIM, you then have very specific task force that have been developed on different topics, such as ecosystem approach, marine protected areas, Arctic marine pollution, such as plastic, resource exploration and development, and Arctic marine shipping. Now, when we look at the ASEAN, we have 2 working groups under the senior officials meeting of the environment. One is on nature conservation and biodiversity, being both terrestrial and marine, and one is on the coastal and marine environment, being both terrestrial and marine. And we have an activity center for biodiversity, also both terrestrial and marine. And the activities, so the impact to the marine environment from activities would fall somewhere between those bodies and the management of those activities under the economic community. So that's sort of, it's interesting, and it points to a certain number of differences, but it also points to possibly some ideas of how we could leverage the similarities and some of the examples that have come out of the Arctic Council. And so, so first, as a main difference, not to be forgotten, is the very low population of the Arctic Ocean along the coast, compared to the South China Sea. There is also a difference in the mandate. I mentioned this before, and beyond the mandate, the political momentum. So when you look at the number of meetings of ministerial meetings of the Arctic Council, it's once every 2nd year, whereas the leaders in the ASEAN meet twice a year. You do have, so in terms of policy making, we do have a greater push and certainly greater dynamics. Neither of them very much like binding agreements. I think political dialogue is very clearly a preferred route of engagement. Now, when it comes to the development of regional scientific knowledge, and that's what I find is very interesting, the Arctic Council shows a lot more work than the ASEAN has. And there's room for progress and development here that would be of great benefit to the protection of the marine environment in the region. Similarly, for regional and project reports, there are, of course, some, but not many are made publicly available, apart from the work of done by CIFDEC, the fisheries regional body. So the civil society is another element for which the Arctic Council, we saw in the constitution of the Arctic Councils, you have accredited.
Youna,
yes.
We are running out of time, so you need to wrap up.
I'm finished.
Yeah.
So so the civil society is not involved in the same way in the ASEAN. Well, the other 2 points that I was making are quite self-explanatory, and there is, very importantly, no working group that's devoted to the marine environment. So that leads me to my last slide, which I'll finish in 1 minute, highlighting what is underlined, which is the lack of regional expert networks in the region and the lack of regional databases and regional knowledge. So we do have, and that's paradoxically, we have, and that's the interesting observation that we might have no time, but if anyone wants to continue the discussion, I'd be really open to that. It's a paradoxical situations because there is more dynamics in the ASEAN to some extent, and yet there is less science and less knowledge that is being shared at regional level. So I'll stop here.
Thank you to both Vito and Youna. Perhaps, Per, have we time for a question?
Yes, we do. We are just on time, but of course we can have a few questions for this interesting topic. Yeah.
Anyone? Just take the floor if you have a question. Are there no questions? I have a question for both of you. Vito highlighted the importance of this possible UN implementation agreement, but the road towards such an agreement is long, and we don't know whether it will be adopted. And at the same time, you pointed out to a very fragmented legal framework. And how do you see an alternative route towards more comprehensive protection of biodiversity?
Do I need to respond realistically, or in terms of what I would think it'd be a good approach? Because I think there has been some steps to strengthen the framework in the Arctic, both within and outside the Arctic Council. And in relation to the Arctic Council, there's been a process to precisely look at what other mechanisms or bodies could be necessary to strengthen the ability to protect biodiversity in the Arctic through a task force that has been established. But unfortunately, that has led nowhere in that respect. There has been calls for establishing a regional treaty in the Arctic, but it also has led to no outcome. So realistically, I think that perhaps in terms of ensuring that there is a firm legal competence somewhere to, and then we can discuss whether marine protected areas would and to which extent would actually help, given the possible turmoils that climate change is bringing in the region. But so that would be perhaps the best hope is that a global treaty is in fact adopted. However, the way of establishing some form of regional mechanism that probably would be maybe the best way to address also the regional circumstances and regional needs, and that is in a way something that plays out also in the negotiations, because so one of the big questions is whether the implementation of this new agreement would be done globally, so through the new body set up in this by the new agreement, or through existing or new regional bodies. So I think one hope is that this instrument would stimulate to establish some strong regional mechanism to implement global rules, but in accordance with the needs and circumstances of the Arctic region. And in this respect, I think the coastal states in the Arctic are playing like a different different tune in the two contexts, because in the Arctic context, they have generally resisted the idea of establishing anything else than a governing mechanism, which is the Arctic Council. So they resist the idea of a treaty, regional treaty. But in the context of the BBNJ negotiations, they resist the idea of global bodies taking charge of, for example, establishing marine protected areas in the regions and therefore in the Arctic, and they would rather see provisions setting out the obligation for states to, where regional mechanisms don't exist, to establish ones. So there is a bit of maybe an idiosyncratic position on the part of our Arctic states, and solving that idiosyncrasy would be maybe an important step to find a way to move forward regionally, even within a global context of this new agreement, if it gets adopted.
Thank you for that for that answer. Youna, perhaps a brief comment at the end, and then we give the floor back to Per.
No, I have nothing really to add.
Okay.
So may I ask or comment on Youna's presentation? Or
very short.
Sure. Yeah, and I just wonder if you thought about this Central Arctic Ocean Fisheries Agreement, where you have suddenly a mixture of some Asian and some Arctic states, and how that could and cannot bridge some of the points that you have highlighted, given that in this Central Arctic Ocean Fisheries Agreement, you have, of course, the Arctic states on the one hand, but then you have the European Union, China, Japan, the Republic of Korea. So, and maybe they, none of them are part of ASEAN, but they're certainly part of that region of the world. So I just wondered.
Yeah, food for thought. Outsiders are not always welcome. So the Arctic is already more internationalized to some extent. I mean, I think to some extent than the, although maybe not. It's an interesting point. I look at the way the way it's been. It's worth considering the way it came about. Actually, who made the first move and who proposed it?
It's a process that started in the context of the Arctic 5. So not the Arctic Council, but the Arctic 5. So this was not really related to the Arctic Council. And then the process was opened up to other players which had already an ongoing interest in the Arctic in different measures, either through activities or, and I think it was actually, that was quite an important process because of this opening up to other non-Arctic players, even though some think of themselves as near Arctic states. So the Arctic is really opening up in many different ways, and I wonder if that could have some similarities with the Asian situation, which I'm not that familiar with. But so it's just really like a comment.
Thank you for that.
I think we gave the final word to Bob. You raised your hand.
Yeah, I raised my hand. I just wanted to make a point as to the question is, how do we go forward? I think in the past we've cooperated with Arctic University of Norway and your Law of the Sea Center on regulation of international shipping. I think the discussion today highlights that there are other areas of common interest where we may be able to cooperate between your Law of the Sea Center and NUS. I think the vehicle, perhaps some way I can pass to Youna, since she is now attending the Arctic Council meetings. Singapore is an observer to the Arctic Council. The Singapore Foreign Ministry is still interested in institutions in Singapore taking a part in research. And I think the natural partnership perhaps is sort of we reinvigorate the link between Arctic University and NUS Center for International Law. So I hope we can go forward on that. And perhaps we can thank Per Stigler for organizing this, maybe bringing us back together in a sense.
Yeah, I totally agree with you. And also my thanks to Per Christian for his insistence on organizing this. We have been a long journey since early this year. Thank you, Per Christian.
Yes. Well, thanks to you, but you're right. We've been working on this for some time. The idea was to have a delegation from University of Tromsø coming to Singapore in April That didn't happen due to COVID, but I'm very happy that we could manage to have this Science Week now this autumn. So with that, I'd like to thank you all, specifically for this session, for all the audience. And this is the last day of this Science Week. It's been a very comprehensive week. Actually, we had more than, I just counted it now, we had 87 speakers and professors and chairs in this over these days, and I hope, and I'm convinced that this will be seed for enhanced cooperation, a refreshment of some relations that I just heard now between the centers of law, but also in the other fields that we've been addressing in decarbonization, in sustainable urban development, and in the ocean technologies and ocean digitalization. So with that, I'd like to thank all of you for your great contribution. I am going to follow up with try to extract some follow-up items, and I would like to have the input from your side as well. So Youna and Vito, please send me your presentations for distribution if you can. And as I also mentioned, we've been taping all these webinar series, and that will be made available as soon as I have kind of wrapped it up a bit. So with that, I wish you a great Friday. I assume we are all turning back to CNN for the exciting developments on the other side of the ocean, and have a nice good weekend, all of you. Thank you very much for now.
Thank you. Bye, everyone.
Bye. Bye.